Okay, welcome to this video where you can revise common topics that appear on paper 2 with me the day before the exam. Now on the screen you can see a checklist that you can now download on the website. This will be different depending on your exam board, but it shows all of the topics that appeared on paper 1 so that you can focus your revision towards the areas with the topics that haven't yet appeared. Now we've got a lot to get through in this video, so we're not going to waste any time. Let's get started. Okay, some error intervals. 6.4 has been rounded to one decimal place and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to one decimal place, it couldn't have been 6.45. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away. So it would be 6.35. Okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to one decimal place. On to the next one. This one's slightly different in the wording. So this one says it's been truncated to one decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5 because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. And the final little one we're going to have a look at here is using your calculator. So it's important to know where lots of digits are. Pick quite a complicated one here, but you just need to have a play around with your calculator to make sure you can find your square root, your cube root, your squared, your cubed, your fraction button, your sin, your cos, your tan, and figuring these out. So I picked quite a complicated one here. So to get your cube root button, depending on what calculator you have, but the majority of them you still have to press the same things. We press shift and then we go for, let's get a different colour here, we go for the square root button, and that allows us to get a cube root. So on your calculator, a cube root will pop up, and then we're going to use the fraction button. So the fraction button is just next to it in this diagram here, the fraction button, and an empty fraction is going to pop up. So on the top, we're going to just type in on the top of that fraction there, 4.3 multiplied by, press your tan button, and then press 39, and normally this will go in a bracket, so remember to close the bracket off there. But you don't put this little degrees symbol in, you just put 39, the calculator knows that you're talking about degrees. So let's get that up on my calculator. We've got 4.3 multiplied by tan, the brackets opens for me, 39, close the brackets, press your down button on the calculator to go into the bottom of the fraction, and type this sum in here, 23.4 take away 6.06. So 23.4 take away 6.06, and make sure at this point you write all the numbers down. That equals 0.585593423. Now some calculators may go beyond this depending on what the answer is on the calculator, but it tends to be that you never really have to go beyond 9 digits because not all calculators will go that far, so you are limited to the amount that some people will be able to write depending on what calculator they use. Now the question will probably usually say then to round your answer to 1 or 2 decimal places. So if we just have a quick think, if we were to round this to 1 dp to 1 decimal place, and we could chop that after the 5 there. So 1 decimal place would round up to 0.6, and we would round that to 0.6. If we had this to 2 decimal places or beyond, let's have a think. After 2 decimal places, let's pick a different colour, it would chop it after the 8, and it would be 0.59 because it's a 5 after that one. Okay, so you could have different ways of rounding this, but just make sure you write down all the digits on your calculator display before actually rounding it. So algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well, not forgetting there's a 1 in front of that. 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7. Well, 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well, 3 times 4 is 12. Y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying 2 brackets, so we'll expand these separately. So let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared. X times negative 5 gives us negative 5x. 3 times x is positive 3x. And then positive 3 times negative 5 is negative 15. And then again, we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got negative 5x add 3x, which in total is negative 2x, negative 5 add 3. And then we've got the negative 15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's negative 4, so it's negative 8x. Negative 3 times 3x is, well, 3 times 3 is 9, so negative 9x. and then negative 3 times negative 4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we have 6x squared at the start, and we've got negative 8, take away another 9x. So negative 8, take away another 9x is negative 17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we have a look at both these pieces, 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus. And 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have 2 things. And let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? Well, we have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. Now we just need to have a look at these numbers there because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have 2 numbers in here with some symbols. So 28, the numbers that times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16, or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7. That'd make minus 3. So plus 4 and negative 7. And that's our double bracket there finished. So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times a number, 3 times x, plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times a number, 3x, must equal 21. And that means 3 times a number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times a number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just writing divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times with the remainder of 3. So we could write it's 4 with that remainder of 3/5 there. or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose, I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side, so 3 being the smaller one. So we can take away 3x from both sides, that's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that -3 there, and that now equals +9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a -9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. And Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris, and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else, so if let's call Chris X, then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, x plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, x plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of x plus 8. And we could even expand that out now, so 2 lots of x plus 8 is 2x plus 16. So we have their 3 ages now in terms of algebra. We have Chris being x, Adam being x plus 8, and Brian being 2x plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have x plus the x plus 8 for Adam, plus the 2x plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. So the perimeter of the quadrilateral is double the perimeter of the triangle. Work out the perimeters. Now the lengths of each shape are given to us as expressions, so we could get an expression for each of the perimeters to start with. So let's have a look at that quadrilateral. Let's write that down over here. So the quadrilateral, we've got lots of pieces here, so let's count up these x's to start with. We've got 2x, plus this one's 4x, 7x, plus another one is 8x, so we have 8 x's. And the numbers, we've got a -3 and a -1, and in total that is -4. So that's the quadrilateral, 8x minus 4, and that's an expression for the perimeter. Then we've got the triangle. Let's have a look what we've got there. We've got 1x, 2x, so 2x. And we've got 3, 4, 5, plus the 4 is 9, so 2x plus 9. Now it says the perimeter of the quadrilateral is double the perimeter of the triangle. So if we double the perimeter of the triangle, then that would be equal to the perimeter of the quadrilateral. Okay, so if we double this one, then those perimeters, those expressions for the perimeters would be equal. And if we double that, we get 4x plus 18. Now, because those two perimeters are now equal, we can set them equal to each other using an equation. So we can say this one here, the perimeter of the quadrilateral now, 8x minus 4, is equal to this one here, double the perimeter of the triangle. So that's equal to 4x plus 18. We can now just solve that like an equation, so we can get rid of the smaller x from both sides, so minus the 4x, So over here we have 4x, so we have 4x minus 4 equals 18. We can now add 4 to both sides, so get rid of this plus 4, so plus 4. And we get, let's do this over here, we get 4x equals 22. And then we've got to finish that off to find out the value of 1x, so dividing by 4, x will be 22 over 4, which is okay if we have a calculator, but 4 goes into 22 5 times with a remainder of 2, so it'll be 5 and 2 quarters, and 5 and 2 quarters is 5.5. So our final answer there, let's bring that up to here, would be 5.5 or 5.5. And again, it would have probably said in the question it was all in centimetres or it was all in metres, so we just have a look at what units we'd apply there, but 5.5 is our value of x. Now it says to work out the perimeter of the triangle, so we can sub these back in if we want. So 5.5 would be here in place of this one, would give us 8.5, so that would be 8.5. 5.5 on the x plus 2 here would give us 5.5 plus 2, which is 7.5, and then this one over here is 4. So if we add those all up, 8.5 plus 7.5 is 16, plus the 4 gives us a perimeter of 20 for the triangle. We could have done the same with the quadrilateral, but it said the quadrilateral is double the triangle, so this one here must be 40. And again, we could have just subbed that into the quadrilateral there and halved it for the triangle, but we've got our two perimeters. Again, just not forgetting what units it was, not that I've put any units in this one. Okay, so when looking at the equation of lines, and specifically when we are looking at parallel lines, we're looking to compare the gradient. Now when we have some line equations like this and it asks two of them are parallel, explain which two, we need to get them all into the form y equals mx plus c, and then we'll have a look at that value of m, which is the gradient. So we're specifically looking at this number here that goes in front of x. So if we look at the first one, we can see that that's 2y. So if we divide everything by 2, that is going to put it into the form y equals. So when we divide by 2, we get 1y is equal to 3x plus, and then we've got to do 5 divided by 2. Now, as that's not really looking at the parallel line or whether it is going to be parallel, we don't need to be too concerned with getting that perfect in terms of a decimal, so we can just leave it as 5 over 2. It's fine to leave it like that anyway, but that's absolutely fine just to leave it and not worry about having to type it into your calculator or convert it. Now for the next one, you can see that that 3x is on the left hand side. So to get that onto the right hand side, we're going to subtract 3x from both sides, and that will leave us with y is equal to a minus 3x, and then we've got the plus 5. So as you can see already, those two have different gradients. For the first one, we have got 3x, and for the second one, we have negative 3x. So we need to have a look at this final one. Now for this final one, it's a little bit trickier because you've got negative y on the left hand side. So to make that become positive y, the first thing that we can do is add the y to the right hand side. So if we add the y over, we would have 3x is equal to, and you can put that as 5 plus y, or you could write it as y plus 5, as that is a positive 5. Now it doesn't matter if the y is on the right hand side of the equation, so now we can get rid of the 5 from both sides, and if we minus 5 from both sides of the equation, we would have 3x minus 5 is equal to y. And of course that can be written the other way around, so we could write that as y is equal to 3x minus 5. So there we go, we have all of our equations done, and as you can see, the third line, which has a gradient of 3, is matching the line 1, which also has a gradient of 3. So in this question here, we would say that line 1 and line 3 are parallel, and the reason that they are parallel, as it says explain which two, is because they have the same gradient and they both have a gradient of 3. Quadratic inequalities. So we're going to solve this. Now obviously these represent a parabola, a curve, a quadratic graph. Again, a quadratic graph here. Normally when we're solving them, we are solving to find these two roots here, or solutions, and you can be asked to represent to find them or to estimate them from a graph. If you've been given a picture, they're referred to as the roots. But when we're solving an inequality, we're looking at something slightly different. Now this first one here, and they're both exactly the same, but we're going to have a look at the two different scenarios. This first one says less than 0. So essentially it's saying is what part of this curve is less than 0. Now if you have a look, this part of the curve is what's below ground, what I like to refer to, or less than 0, 0 being the x-axis there, So really all we're going to say is, well, what part of the curve is between these 2 points below 0? So if we actually just factorise this to find out what these two roots are, so putting it into a double bracket, again it might have a coefficient bigger than 0, but I'm just going for a nice easy one here just to show you the process. So the factors are 24, we can have 4 and 6, 2 and 12, 3 and 8, so I'm just going to not write them all down because I've already spotted it's 3 and 8, but that would be plus 3, minus 8, and that would give us minus 5. So our roots here, our solutions are x is negative 3 and x equals 8. So if we were to label those on the graph here, this would be minus 3 on the x-axis and this would be 8. Now the bit that is below the curve is between negative 3 and 8. So I'd have to write this as one of these types of inequalities. Okay, where we say it's between 2 points. And that would be my answer there. X is between negative 3 and 8, or the part of the graph that is under 0 or less than 0 is between those two numbers. Now that would change slightly for this one down the bottom, because I've just realised they're pointing the same way. That wasn't meant to be pointing that way. Let's change that. That's meant to say bigger than 0. Okay, so there we go. Sorry about that. Let's change that. X squared minus 5x minus 24 is bigger than 0. So this would be something slightly different now, because the bit that's bigger than 0, and if I just redraw this graph, there we go, 8 here, negative 3 here. The bit that's actually bigger than 0, we've got one part over here, and we've got a completely separate part over here. So we've got two separate parts of the line, and that means I can only write this as two separate inequalities. Now this part on the left is all this part of the curve is going to numbers less than 3. So my solutions there would be, well, anything that's less than 3. Sorry, negative 3. So x is less than negative 3. And that's one of my solutions for that part of the line. But I've also got the other part, and that is going to all the numbers bigger than 8. It's going this way. So my other solution would be x has also got to be bigger than 8. So I've got two solutions here to write with my inequalities. I've got all the x values less than negative 3 and all the x values bigger than 8. So that's solving a quadratic inequality. Just got to think about which part of the graph you're actually looking at. Okay, so we've got a functions question. So we've got f of x is 2x minus 4 and g of x is x squared plus 5. Now the first one we're going to have a look at is this here. So working out an inverse function. So an inverse function just means basically doing it in reverse. So the function of f is 2x minus 4. It times a number by 2 and then takes away 4. There's a nice way of doing this algebraically. We can change that f of x piece there for a letter. I'm going to just change it for the letter y. So y equals 2x minus 4. And I'm just going to rearrange it to make x a subject, which is hopefully quite nice and easy in comparison to the one we looked at earlier. So add 4 to both sides. You get y plus 4 equals 2x. And then divide both sides by 2. You get y plus 4 over 2 equals x. There we go. I'm just going to rewrite that with x instead of y, and that'll be the reverse function there, the inverse function. So instead of being y plus 4, it's x plus 4, so x plus 4 over 2, and that equals the inverse function of f, so f minus 1x. There you go, and that's how you do your inverse function. And that can be done for any type of function here. Just swap the x and y, rearrange it to make x a subject, and then rewrite it. Okay, on to the next one. It says work out g(f(x). So you could be asked to put a number in. This isn't actually asking us to put a number in. It's saying g(f(x), which means I have to sub one of the functions into the other. So if you read this, it means what is the function of g when you put f into it? So what is g when you put f into it? So, well, g's up here. So all we've got to do is put f into it. So if I stick f into there, and the way that I do it is I stick the function of f in a bracket, and I'm just going to replace the x value here with that bracket. And if I do that, I get 2x minus 4 in brackets squared, because it's x squared, and then plus 5. So really there is an expression for that, but I'm going to completely expand it and simplify it all down. So we have a double bracket, we have 2x minus 4, and another 2x minus 4. And then once we've expanded that, we just need to remember to add 5. So if we expand that, and again, I'm going to skip some steps here. I'm going to do 2x times 2x, which is 4x squared. And then we've got 2x times minus 4 and 2x times minus 4 again. So minus 8x is minus 16x. And then 4 times 4 gives us 16, but we're going to add 5 to that. So that'll give us 21, so plus 21. And there's your expression for that. You could have had this written in a different way. You could have had f gx, and in that case you'd do it the other way round. It says what's the function of f when you put g into it, so you put your bracket round g and slot it into the x place in f. So you can have two different ones there as well. Just got to make sure that you do them in the right order. You could also be asked to sub a number in, so it might say something along the lines of f, let's do it the other way around, fg, I don't know, 2. And in that case, that means what's f when g is 2? So you put 2 into g, and if you put 2 into g, you get 2 squared plus 5, which is 9. And then you put 9 into f. So what is f when g is 2? Well, when g is 2, we get the answer 9. So you stick 9 into f. So putting 9 into f, which is our first function there, you do 2 times 9, or 2 lots of 9, take away 4. 2 lots of 9 is 18, take away 4 is 14, so that would be our answer there if it asked us to sub a number in. But these ones are a bit harder when you have to put a function in and remember what order to do it in. But just remember the way you read it. So for this one, we looked at what is g when you put f, the f function in. And there's some functions for you. Okay, so for this graph here, all I'm going to do is I'm going to have a look at the x values. I'm going to plug them into my little formula. So just like when we're drawing normal line equations, it says here to get y, we do sine x. So let's pick an x value. Let's start with 0. So if I type in sine 0 on my calculator, I get the value of 0. So I'm going to plot that as a coordinate. So that's 0, 0, and that is going to go there. Then I'm just going to move along the x-axis. So I'm going to do 30, and then I'm going to do 60, 90, 120. I'm going to go all the way up to 360. I'm going to try and do them as quickly as I can. So I'm just on my calculator now. I'm just typing in sine 30, obviously inside the bracket there, and I get a half. So I'm going to plot that as best as I can. It's quite nice on this graph here, and that's 0. Going back in, we get sine 60. Okay, and that gives us quite a nasty number there. We get root 3 over 2, obviously, which you might know from the exact values of trig if you check that video out. But as a decimal, when I convert that into a decimal there, it gets me 0.86. Now, I can't get that absolutely perfect, but I can get it near enough. I'm going to put it around here, 0.86, and I'm going to go back in and put sine 90 in. There we go, sine 90 gives us a value of 1. And there is our first little part of this curve that's going to go up there. Now, when I go for the next one, when I go for 120, if I go back in, I'll type in sine 120. There we go, I get 0.86. I actually get the same value as when I put in sine 60. There we go, and we'll discuss that a little bit more in a second. Okay, moving along, sine 150, that gives me a value of a half again. There we go, and then sine 180 gives me a value of 0. Right, so we've got like this sort of like hill-shaped little curve there. Kind of looks like a little wave at the moment, which you might recognise from some of your science graphs as well. So on to the next one here, putting in 210. Let's have a look. Let's put that in, 210, and we get negative a half. So that's negative a half just here. And then when I put the next one in, I get negative 0.86. There we go. So we're getting these same values as we got up there, but in the negative versions now. When we put 270 in, we get minus 1. And then we get the negative 0.86 again for 300. Again, we get a half for 330. I'm just typing in this last one here, 360. And there we go, we get 0 for that one. Right, I've typed those in quite quickly. Obviously, just take your time working through those with a calculator. And you will see we'll get these values here. And obviously, we want to just join that up with a nice smooth curve. There we go, and it makes this like almost like wave shape. There we go. And that's our sine graph there. So obviously, there's a few little bits along there that are worth discussing. One of those being some of the fact that we get these same values at different places. We actually get some sort of almost like a little reflection line within the curve. If I was to draw like a little reflection line up here, it's almost like a mirror image there on the other side of each part of the curve, just on that little sort of positive slope there. Obviously it changes as we get into the negative, but we could almost think of it like that. There's something worth noting with these values, the fact that the value of 30 there, sine 30, was the same as sine 150. Let's just draw that out. We've got sine 30 that equals a half, and you also had sine 150 that equaled a half as well. There we go. And if you have a look, these values or these angles here, as we start to look into the sort of trigonometry a little bit further, those two angles, 30 and 150, add up to 180. So these sort of supplementary angle pieces have the same values there, and that actually applies to any of these. If I was to look at sine 20 and sine 160, they both have the same value as well. Let's just type those in. Sine 20 gives us a value 0.34 with a few more decimals, and sine 160 also gives us that same value, 0.34. So you feel free to have a little go with that and have a little play around with some of those values, but it's because we get this sort of mirror image on either side of the trigonometric graph there. Okay, but that is the sine graph. Another thing that you might note as well is that it does go through the origin, and I kind of always remember, and it's a little bit silly, but sin has that word in there, and I always kind of remember sin is in the origin, so it's just a little silly way of remembering it, but sin is in the origin can just help to determine or distinguish between the sine and the cosine graph. Okay, but sin is in the origin, and then we're going to have a look at the cosine graph now and actually go about drawing that as well. So let's have a look at that one. Okay, so for this one it says on the grid draw the graph of y equals cos x, and again it's between 0 and 360, so we're just going to plug our values in on the calculator again, and we're going to do that for cos x. Now let's have a look. So cos 0 this time gives us a different value. We get 1. Okay, and this is obviously what distinguishes this one between the cos graph and the sine graph. This one is not in the origin. It starts at 1 there. And as we start putting values, you're going to see quite a similar pattern to the one we had before, but it's obviously just starting from 1 this time. So if we put cos 30 in, let's have a look. I put 2 brackets in by accident. So cos 30, we get this 0.86 value again that we got before. So 0.86. It's just there, and we put cos 60 in, and we get half. Cos 90 gets us 0, and then it starts to dip below again. If I put cos 120 in, that now dips down to minus a half. Then we get minus 0.86, then we get minus 1, then we get minus 0.86 again, minus a half, 0, a half, 0.86, and cos 360 finishes on 1. There we go, so we get this same similar shaped curve, but it's obviously starting at 1, which has just sort of shifted that curve along a little bit. There we go, and that is our cosine graph there. Okay, but again, it's just plugging numbers into a calculator, plotting the points nice and carefully, joining it up with a nice smooth curve. Okay, so don't be put off by these types of questions. Literally, it's just typing numbers into a calculator and plotting these coordinates. Obviously, on both of these graphs here, one other thing that you might have noticed is it always fluctuates between 1 and down here at minus 1. And that is also another key point here with our trigonometric graphs, is that it does fluctuate between 1 minus 1. But that is our sine and cosine graph, and now we're going to have a look at our tangent graph and see how that differs from these two, because there's not much similarity at all between these two and the tangent graph. It looks completely different, so let's have a look at that one now. Okay, so here we go. We're going to draw the graph of tan x, okay, between 0 and 360 again. And you're going to see this one's quite unique in terms of how it looks compared to the others. So to start with, I'm going to put tan 0 in on the calculator again. So just to confirm, on my calculator, I am literally just typing in tan 0 and pressing equals and getting my answer. And for that one there, I get 0. So tan 0 starts on 0. And I'm just going to put that coordinate on again. Now if we'll go for tan 30, I'm just going to move along the axes there, and we get 0.57. I'm going to try and plot that as best I can. Again, we are only doing a sketch here, so 0.57, somewhere around about there. It's not perfect. Let's go back in. Tan 60, and we get root 3. Let's convert that to a decimal. We get 1.73. So 1.73 is somewhere here. And then we'll go for tan 90. And our calculator says maths error. There we go. So I can't actually put tan 90 in. And obviously, if you've checked out that video on the exact values of trigonometry, you'll know that tan 90 is undefined. Again, I'm not going to discuss the ins and outs of why it's undefined, because you'll be able to have a look at that in the exact trigonometric values video, which is obviously in the description. But for that one there, we can't plot a coordinate. So I'm going to skip out 90. I'm going to go over to the 120. So tan 120. And that gives me negative 1.73. So for 90, it's down at negative 1.73, just there. Okay, so we're kind of thinking, hold on, how does this form a pattern? This is looking a bit strange at the moment. I've just plotted that in the wrong point, so it's definitely looking strange. That's under the 120. There we go. That's 120 there. Back in, let's change that for 150. Let's see where this is going. So it's minus 0.57. So that's going to be there. Then we've got 180 to put in, so tan 180, and that gives me the value of 0. There we go, on to 210, and that gives me positive 0.57, so we're starting to see a bit of a pattern here. We've got that 0.57 going in again, and then we put the next one in, we get our value up here. There we go, so we're starting to see a bit of a pattern here. We've got an almost bit of a wave, and now we're moving on to the 270, so we put 270 in again. And again, we get a maths error. There we go. So we're going to have to skip 270 out. Okay, we can't do 270. It matches what happens on the 90 there. So we're going to go over to the 300. So tan 300. And again, I get negative 1.73, which is here. And on the next one, we get our minus 0.57. And on the next one, we get 0. Right, there we go. So that is our tan graph. It's a little bit odd, but when we actually join this up, we get a sort of wave here, we get a wave down here, and we get another wave there. And it's a little bit weird. There we go. If I was to actually draw lots of these out, you'd see that this line would continue down there, this line would continue up here, and we get this sort of pattern of waves that's sort of going along the x-axis there. But that is our tan graph. It looks a bit strange. It looks a lot different to the others. It sort of seems a bit counterintuitive when you do draw these on the, you know, if you were to do this on the calculator, because you have these sort of gaps from here to here, and you're kind of thinking, well, hold on, how do I join these up? But they don't join up at all. Okay, they're sort of just skipped out there because we have an undefined value of 90, so it all starts again. Okay, there is lots of mathematical language behind that, but to be honest, all we need to think about in this video is how we go about drawing it, how we would answer this question on an exam, and there we go, there it is, just plugging those numbers into a calculator and having a little bit of an understanding of what the graph actually looks like. So there we go, that is our sin, cos and tan graphs and how to draw them. Hopefully seems quite nice and simple, just plugging the numbers into the calculator and plotting them on the graph, and then actually just thinking about recognising them. So we had the sin graph, which was that nice wave fluctuating between 1 and -1 that started in the origin. We had the cos graph, which was pretty much exactly the same as the sin graph, but it just started on 1 and formed that nice little wave between 1 and -1 again. And then we've got our tan graph here, which is obviously quite different, but again, just a nice little method for actually drawing them and plotting this and just making sure we've got nice smooth curves. And obviously just making sure that you do have a nice smooth curve that goes through all the points, so not like my little rubbishy one that I've done here, where we've actually missed out a coordinate there. You'd want to have nice smooth curves going through all of those. But right, that is our 3 graphs, and we're going to use some of the ideas from these graphs to actually have a look at some of these quite nasty questions and see, just have a little talk about how we would sort of approach those in an exam. So let's have a look at our first one. Okay, so same question that we were just looking at, but we've got some questions here that we're going to have a look at actually answering here. So it says the diagram shows the part of the curve with the equation y equals f of x, and here it is in the diagram. The maximum point of the curve is 2, 3, as we've already seen. Write down the coordinates of the maximum point with these different equations, and I've got quite a lot here, all the different scenarios we could actually have a look at. So for part A there, okay, it says f of x minus 2. So that's inside the bracket, so it affects the x coordinate, and it does the opposite of what we'd expect. So it doesn't subtract 2, it adds 2. Okay, so it just does the opposite. So the x coordinate being 2 there, we would add 2 to the x coordinate, and that would make it 4. And the y coordinate's not going to change, so that would stay as 3. Okay, so that's the opposite of what we'd expect, and we add 2 to the x coordinate. Looking at the next one, let's try to change to a different colour here. Right, so f of x minus 1. Now that minus 1 is outside of the bracket, so it's outside the bracket, it affects y, and it does exactly what we'd expect. So minus 1, we would expect that to subtract 1 from the y coordinate, which it does. It just changes the y-intercept actually. If you're familiar with your equations of lines and your coordinates, coordinate geometry, you should hopefully know that number at the end is the y-intercept there. So it's taking away 1 from the y-intercept, essentially just moving the graph down 1, but we'll have a look at that again a little bit later. But minusing 1 from the y coordinate currently is 3. So if we take 1 away from that, the x coordinate doesn't change, so 2. But the y coordinate's also going to drop down there to 2. It's going to subtract 1 from that. Okay, so that's how we could have different scenarios there with just adding and subtracting numbers and how that affects the x and y coordinate. Now we're going to have a look at question C, part C there. So y equals f of 2x. So 2 times x. Normally when you're timesing by 2, you'd expect that to double something, but as it's inside the bracket affecting x, it does the opposite. So rather than multiplying by 2, it divides it by 2 or halves it there. So if we look at the x coordinate is currently 2. So half of that, halving it because it's inside the bracket and changing the x coordinate, but does the opposite. So half of 2 is 1, and the y coordinate remains unchanged, and that remains as 3. There we go. So that's that one. Let's have a look at the other scenario where it's outside the bracket. So 3 lots of f of x for part D here. Let's have a look at what this does. So it's outside the bracket, it affects y, we're multiplying it by 3. So it does what we'd expect, it makes it 3 times bigger, but it affects the y coordinate this time because it's outside the x bracket. So 3 lots of that y coordinate, the y coordinate's currently 3, so the x coordinate is unchanged and the y coordinate gets multiplied by 3 and becomes 9. Right, there we go. So that is our scenarios where we are multiplying by a number. So in terms of the x there, inside the bracket 2x does the opposite, so divided by 2, but outside the bracket it multiplied the y coordinate by 3. Okay, and onto these negative ones here which don't really follow the same trend, but partly it does. So we'll have a look at this one here. So when we've got minus x in there, now it doesn't do the opposite of what we'd expect, because the opposite of minus x would just be nothing, okay? We wouldn't actually change anything at all, it'd just be positive x, it'd be the same equation, okay? But we follow the rest of the rules for this one. It's just that it goes a little bit out the window when we look at our minuses here. So when we've got a minus in there, all that does is it swaps the symbol of the x coordinate. It's still affecting x, it's inside the bracket, it just doesn't do the opposite this time, okay? So it just changes the 2 as the x coordinate to minus 2. So the x coordinate's going to change, it becomes minus 2, and the y coordinate remains unchanged, stays as 3. Okay, so this when there's a negative in there, that's the only scenario where it doesn't actually do the opposite or anything like that. We just have to worry about, is it next to the x or is it changing the y, and it just flips the sign. So the last one here, we've got y equals minus f of x, and again the minus there is outside the bracket, so it changes the y coordinate, and again it just swaps the sign. So instead of being positive 3 there as the y coordinate, it's going to be negative 3. So we have positive 2 still, and negative 3. Okay, so again, just following all those little rules. Is it next to x or is it next to the y, or outside of the x bracket? And that tells us which coordinate it affects. When it comes to adding, subtracting, multiplying, okay, we can think about the opposite or whether it does what we'd expect. The only scenario where it doesn't is where we've got this little minus symbol in there, and that just changes the positive or negative symbol of the corresponding coordinate, whether it's x or y, whether it's inside the bracket or outside the bracket. Okay, let's have a look at one more. Okay, so I've got 5 questions here. They're not in any particular order of difficulty, they're just some sort of different trigonometric questions where we're looking at these graphs and sort of thinking about how we would approach them. But feel free for any of these 5 questions to just pause the video. Obviously, if you've got the worksheet printed off, you can have a go at the questions, see what you get, see if you can sort of apply any of these little calculator methods to answering them. And then obviously, I'll go over all the answers anyway, so we can have a look at all these sorts of questions. So it says here, the graph of y equals sine x for x values from minus 270 to plus 270 is shown below. And obviously that is shown on the graph there. We've got minus 270 all the way over to 270 over here. It says on the same axes, draw the graph of, and we've got y equals 1 minus sine x for values from minus 270 to plus 270. So that's the graph we're going to have to draw there, and that doesn't look very nice. Now this is all sort of, this question here is very much linked into graph transformations. We're actually transforming this graph, and we just need to figure out how this graph is transformed, but actually we can actually do this on a calculator. Now this particular graph transformation here has got 2 different transformations going on, and we could rearrange that. We don't have to write 1 minus sine x, we could write negative sine x plus 1, and just sort of rearrange those if we wanted to. So we could do it like this, we could write minus sine x plus 1. Oh, missed my bracket there, let's put that back in. There we go, plus 1. And think about what these transformations actually represent. So that negative in front of the sine x flips the y coordinates from being positive to being negative. Obviously check out my video, and in fact I'll link that in the description below on graph transformations as well, because it's probably worth checking out because it does link very strongly into these trigonometric graphs. So that negative there relates to a flip or a change of the symbols in front of the y coordinates. We've then got the plus 1 at the end, and again that's outside the bracket. It changes the y coordinate, it changes the y-intercept, it moves the whole graph up by 1. So you could actually take a graph transformation approach to this. You could try flipping it over and then shifting it up 1, and we could probably do that quite nice and quick. I'm going to do it in 2 different ways though, but just if you are quite keen on your graph transformations, you could first flip it over and just think about that by flip. Oh, that's not my pen, let's just change that. We could take all of these little coordinates here, this one, this one, this one, and this one. I've not bothered with the zeros because they'll stay where they are. And we could just flip them down, change the coordinates there, and that would move the coordinates here. And we actually end up with, and I'll try and draw it. There we go, we end up with that. And then we need to shift it all up by 1. So take all those coordinates, shift them all at 1. That would shift it at 1, that would shift it at 1. Let's have a look. These 0 coordinates need shifting at 1 as well. I'll try and shift them all at 1. It's not the nicest now when you start drawing all over this. There we go. Shift that all at 1. And it makes this sort of curve here. There we go. So drawing it using a graph transformation approach. Let's just get rid of that red one. There we go. That is where our curve ends up following this graph transformation. Okay, not the nicest though, that's quite nasty actually. It's a very sort of horribly difficult graph transformation question, having to sort of flip it over the x-axis there and then actually shift it up one as well. But I'm going to take a little bit of a different approach. But just so you know, you could actually take that approach there using graph transformations. So obviously check that video out if you're not sure on that. You can always have a think about what I've actually done there once you've had a look at that. Now instead of doing that, I'm just going to take this nice calculator approach, because this was actually a calculator question as well. So rather than doing that, I'm just going to plug my numbers into this formula here. So I'm going to start with negative 270. So I'm going to do 1 take away, and I'm going to do sine minus 270. There we go. And that's going to give me my first value. So 1 take away sine, and I'll put minus 270 in the bracket, and I get the value of 0. There we go, so that's my 0. Then I'm just going to change that for the negative 180. So I'm just going to put minus 180. I'm just going back into my calculator and changing that value. That gives me that value there. Back in, negative 90. There we go, and that gives me 2. So negative 90 is up here at 2. I'll put 0 in, and that gives me 1. There we go, we'll put 90 in. And that gives me, sorry, I'll put that in, 1 minus 90, yeah, that gives me 0, there we go. Then put 180 in, the last one nearly done, and that gives me 1. Where's that gone? 1 is there, and then 270. There we go, and that gives me 2. And that is there. And again, just drawing that up with a nice smooth curve. Best you can. There we go. And there is our transformed graph. But again, two different methods that you could take to approach that. Obviously, if you're really good with your graph transformations, you could have flipped it over first, changed the y coordinates, made them positive, negative, and the negative one's positive, and then obviously shifting it up one, doing that transformation with the 1 at the end, changing the y-intercept. Or you could just take this approach, just plug in the numbers into the calculator, plot them all nice and neat, and connect them all up together. So it's up to you which one you prefer, but just a couple of different ways that you can actually approach that question. Right, let's have a look at our next one. Okay, so this says, here is the graph of y equals cos x between the values minus 180 and 180. And again, we can see that on the graph. It does stretch from minus 180 to 180. It says on the grid, sketch the graph of y equals negative 2 cos x, but again, between these values. Okay, so taking a little approach to this then. I'm just going to take the calculator approach. Now again, you could take a graph transformation approach to this, but let's have a look at the end and see what that graph transformation is. We'll take that calculator method to start with and just start plugging the values into this formula. So we've got y equals negative 2 cos x. So on my calculator, I'm just going to type in negative 2 cos, and I'm going to start with that first value on the x there, which is negative 180. So minus 2 cos, and then negative 180 in the bracket, and it gives me the value of 2. There we go, that equals 2, and I'm just going to do that same approach for all of them. So that 2 goes up to there, and there we go. So back into the calculator, I'm not going to sort of do all the little sub values in between. I'm just going to go straight for negative 90 and see where that is. So negative 90 ends up at 0, there we go, so that stays where it is. I'm going to go for 0 now, so back in, negative 2 cos 0, and that gives me a value of negative 2. And let's go back for 90, negative 2 cos 90, gives me a value of 0, and negative 2 cos 180 gives me a value of 2. There we go, so that value of 2 is there. And again, we just need to join that up with a nice smooth curve. There we go, and that's our point drawn there. So again, that's one method that you could approach. If I swap to a different colour here, we'll have a think about the graph transformation as well. So negative there flips the coordinates over. So I could have actually started by flipping those coordinates over. So let's go about doing that. We've got this one here, which is going to flip to the other side there. 0, that one there stays where it is. This one here on 1 flips down to minus 1, which I can just about see. It's about there somewhere. We've got the one on the axes then, which stays where it is. And we've got this one down here, which flips up above. So the minus part, okay, just like before, changes the symbols in front of the y coordinates. So we can draw that in. Okay, I'm going to get rid of this in a sec. And just about draw that in, there we go. So that's what the negative part does, and then you've got the 2 there, and again this is all linked to graph transformations, but the 2 is going to double the y coordinates, okay, outside the bracket, not affecting x, it affects the y coordinate, does what we expect, 2 multiplies the y coordinates by 2. So this coordinate here that's currently at 1 goes up to 2, which is there. 0 stays as it is, This one here, which is at -1, goes down to the -2, which we've got here on our actual graph. Again, 0 stays where it is on the next one, and then again finishing it off with this one, that 1 there goes up to the 2. So you could actually take a graph transformation approach again. Again, I think it is actually a bit harder than just type it in on the calculator, but just so you know that there are multiple methods that you could use here. There isn't just one way to solve these sorts of questions. But there we go, that is our final answer there with our nice green line that we've drawn in. I think just taking a calculator approach was a lot easier, but obviously if this was a non-calculator question, and this was actually a calculator question, but if it was non-calculator, you would have to know those graph transformations there, but this would be a particularly nasty question if it was a non-calculator one. Right, okay, so let's have a look at our next one. So Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again, with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400, 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640, and we could subtract 640. So 3,200 take away 640 will leave us with our answer for the final year. Take away 640 there gives us 2,560, and we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560, 10% of that is 256, so 20% will be 512, and then we can subtract 512. So 2,560 take away 512 leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1-point number there, we've got 0.8. So we could just times it by 0.83 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. James shares some money in the ratio 4:7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4:7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them. So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go. So they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5. And there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. So a mobile phone costs £480 in the UK and the same phone costs $600 in America. The exchange rate is £1 to $1.29, where offers the cheapest price. So we have two options here. We could put them both into pounds or we could put them both into dollars. I'm going to decide to put them both into pounds. So as we can see, we've already got the cost in the UK is £480, but we're going to have to convert this $600. So looking at our exchange rate, the actual number itself, we get a bigger number in dollars. So we know that our answer here is going to have to get smaller. So we only have one decision to make, and that is either we times or we divide by this 1.29. Okay, so it's times or divide. Okay, but we know logically we're going to get a smaller number in pounds. So let's go for this. When we do convert back, we are going to divide. So it's going to be 600 divided by 1.29. And we'll do that on the calculator. 600 divided by 1.29 gives us, not a very nice number here, £465 and 12p to the nearest penny. Now it doesn't matter about all the decimals after that, because at the end of the day we're looking at which offers the cheapest value, and as you can see there, £465.12 is cheaper than 480. Obviously there is another way of doing this. We could convert them both into dollars. So instead of doing that, what I could do is times this number here by 1.29, and 480 times 1.29, if again we work that out on the calculator, gives us an answer of, in dollars, $619.20. And again, that's more than $600, so again we would state that it's cheaper in America. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. If we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go. 1 jar is 250, and 1 tin of beans was 360. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours. But this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take 1 tap or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours, while one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. Okay, on to some direct and inverse proportion. So there's 2 formulas that we can use here. It says A is inversely proportional to B. So it's either going to be A equals K lots of B, or A equals KB, or it's going to be A equals K over B. So these are the 2 that you have to remember. Now with inverse proportion, it's this one here, where K is being divided by B. So we're going to use that formula, so just make sure you write them down straight away. And then it gives us some values to put in. So it says 15 for A, so 15 equals K over, and it says B is 4. So we can solve this for K, we can times both sides by 4 to isolate K there, and we get 60 equals K, or K equals 60. And now what we can do is we can put that 60 back into the original formula here, and that will give us our formula. So A equals 60 over B. And that is a formula for A in terms of B, and sometimes you might just be asked just to write a formula for A in terms of B, and there it is. But this question says find the value of A when B equals 12. So all I've got to do is stick B equals 12 into my formula down here. So if we do that, I'm going to do it to the side, we get A equals 60 over 12, and 60 divided by 12 equals 5. So our final answer there is 5. So every time you just think which formula am I going to use, plug your pieces in, find your value of K, and then reuse that in your formula for whatever values you need. Okay, so this question says directly proportional to. So we're going to be using the other formula this time. It's A equals KB. But you've got to read the question carefully, because this one says directly proportional to the square root of B. So I need to put a square root in with my B. So using the same formula, but just putting my square root in. Remember, it could say squared or cube rooted or anything, but that's my formula I'm going to use. Then it says when A is 18, B equals 16. So if we put those values in, A is 18, so 18 equals K, and I'm going to put a times sign in here, the square root of 16, and you can do that in your head hopefully. The square root of 16 is 4. So I'm just going to put K times 4. Now again, we can actually find the value of K here. We can divide both sides by 4. So if I divide both sides by 4, we get a decimal here because it's 18 over 4. So 18 over 4 equals K. Now if we simplify that down, let's have a look. Divide top and bottom by 2, we get 9 over 2. Which we can either leave as that or we can turn into 4.5. I might just leave it as 9 over 2 for the moment, see where we end up with this, but we've got our value of K. So if we put that back into our formula now, so just putting that back up here for our value of K, we get A equals 9 over 2 root B. There we go, and there is our formula for A in terms of B. A is 9 over 2 or 4.5 times root B. And then it says find the value of B when A equals 2. So if we put those into our formula there, A equals 2, so 2 equals 9 over 2 root B. There we go. Right, so we need to rearrange this. So I need to divide both sides by 9 over 2 or divide both sides by 4.5. If we've got a calculator, that's fine. If we don't know, we can just do 2 divided by 9 over 2. Remember in fraction rules, that would be 2 over 1, and you would times it by the flipped version, 2 over 9, and that would give us 4 over 9. So 4 over 9 equals root B, and if you've got a calculator you can just type that straight in. So 4 over 9 equals root B. In order to find out what B is, we just need to square both sides, and when you square both sides there, 4 squared is 16, 9 squared is 81, there we go, and we get 16 over 81, so our final answer there is a fraction. There we go, just following those normal fraction rules there. That would have been absolutely fine with a calculator, but just a different way to approach this if it is non-calculator. Okay, so when looking at pressure, force and area, you will be given the formula. So pressure is equal to force divided by area, and this question says find the pressure exerted by a force of 900 newtons on an area of 60 centimetres squared. And it says to give your answer in newtons per metre squared. Now, if you were to just plug these numbers into the formula, we would get that pressure is equal to 900, the force, divided by 60. And that would give us an answer of 15. Now, the problem with that is that answer there is in newtons per
centimetre squared, but it says here to give your answer in newtons per metre squared. Now I think the easiest way to go about this is just that rather than using the 60 centimetre squared and putting 60 down here, we just convert that 60 centimetre squared into metre squared. Now in order to do that, if we think about the conversion from centimetres to metres, 100 centimetres in 1 metre, so you divide by 100. So when converting the area unit for centimetre squared to metre squared, instead of dividing by 100, we just divide by 100 squared. So if we go about doing that, and you can type that in your calculator, 60 divided by 100 squared, and on a lot of calculators that's going to give you the answer as 6 times 10 to the power of minus 3. Now hopefully you can get that into a decimal. You just need to hop the decimal 3 places to the left over the 6, and that's actually equal to 0.006. And again, a lot of calculators will just give you that value instead. So in order to go about doing this then, all we need to do is take our metre squared value and put it into our formula like we did before. So we'd just do 900, and instead we'd now divide it by 0.006, and that now gives us an answer in newtons per metre squared, and it gives us an answer of 150,000. So there's our final answer. That is in newtons per metre squared, and that would be our final answer for this question. But of course, just being careful on these questions that you read the units that it wants it in, and I would advise changing the area units rather than trying to change the newtons per centimetre squared into newtons per metre squared.
Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down. And that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2. And there we go, we can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well that you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point minus 1, 0. So first thing to do is obviously to locate that point, which is minus 1 across, not up and down, so minus 1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape, let's have a look, it would go to here on your tracing paper and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just said a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so we've got a transformation here. It says enlarge shape P with a scale factor of -1/2 with the centre of enlargement 0, 0. So always mark out your centre of enlargement first. And an enlargement with a negative scale factor and a fraction here means that we've just got to do this very, very carefully. Now the first things first, you need to pick a point on the shape and just figure out how you get from the centre of enlargement to that point there. And if I just count that, that's 1, 2 to the right, and 1, 2, 3 up. Now all I need to do this, and it's going to be quite small on this diagram, is I just count in the opposite direction by whatever the scale factor is. That's what the negative is. So rather than going from 0, 0, rather than going right and up, I'm going to go left and down. But it's a scale factor of 1/2, so I need to also halve those distances, just as if it was -2, I would double those distances. But for -1/2, so I'm going to go left 1 rather than 2. And I'm going to go down, rather than going up 3, I need to go down 1.5 or 1.5. So 1.5 gets me to there. There we go. So that's 1.5. I'm going to do the next one in a different colour, so I'm going to pick this point here, and let's just think how we get to that. Let's get rid of some of these markings here. There we go. So to get to that, we go 1, 2, 3, 4 across, and 1, 2, 3 up. So I'm just going to halve that again. I'm going to go 2 left rather than 4 right. So 1, 2, and then that 1.5 down, which again gets me down to there. There we go. And that is that point. Then again, I just need to repeat the process for the last one. You might be able to start to do these in your head once you've had some practice, but if we do the last point here, being the top one, let's just see how we get there. So it's 1, 2 across, just like it was to that red one, and then we've got to go up 1, 2, 3, 4, 5, 6, 7. So half of that's going to be 3.5. So I'm going to go 1 to the left. Okay, so I need to go down 3.5, 1, 2, 3.5, just there. There you go. Obviously you can do all this in pencil to keep this all nice and tidy, but when you've got a negative scale factor, you're just going to go backwards in the opposite direction by whatever that scale factor is. Obviously join it all up nice and neat, and there we go. And that is that one there. Just always go back and double check. So it was 7 up, so we went 3.5 down. That's absolutely fine. The other one was 3 up, and we went 1.5 down, half of that. And the other one there, perfect. Okay, so you can see with these, it does actually get bigger, and it gets bigger or smaller, and it rotates 180 degrees, and that's what a negative enlargement does to a shape. Okay, so we're going to have a look at another one here. Okay, so it says describe the single transformation that maps shape B onto shape A. This is quite nice. Hopefully you can tell that it's an enlargement, okay, because obviously one's got bigger and smaller, and we're going from B to A. Now what you can do is you can get your ruler, and I'm going to have to try and do this quite carefully, but you get your ruler and you join up the similar points. Now the similar points are here and here. Okay, obviously it's been rotated 180 degrees. Now if you get your ruler and join that up, you end up with a little line like that. And then you just do that for all the other points. So I can probably get away with just doing 2, we'll have to wait and see. So if I join up these 2 similar points here, there we go, they join up just like that. And what you'll find is that there's this little crossover point, and that tells you where the centre of enlargement is. So I know that it's an enlargement, we've already got that, so I'm going to have to state it's an enlargement. Okay, so it's an enlargement. I've got to get what the scale factor is. I haven't got that quite yet, but I'll have a look. We know it's negative as it's getting this 180 flip. So we know it's negative. We'll come up with the number in a sec. And I know where the centre of enlargement is. So centre of enlargement. And we just write down what that coordinate is, and it's 2, 2. So centre of enlargement, 2, 2. Now to count that scale factor, we're just going to count this side here maybe, and this side here, and just see how much bigger it's got. So that's gone from a length of 1 to a length of 3, so that is a -3 scale factor. So it's an enlargement, scale factor -3, centre of enlargement 2, 2. And you can use that approach for any of these enlargements, whether it's negative or not. Also, you might just want to note here that if it had been from A to B, it would have been the other way around. It would have gone from 3 down to 1, and my scale factor instead, if I was going from A to B, it'd be exactly the same description there, but my scale factor would be -1/3, because it's getting 1/3 of the size going the other way. Okay, so 2 different ones, but the description would be exactly the same there. Okay, so we're going to have a look at some circle theorems. For the purpose of keeping this video as short as we can, I'm only going to go over a couple of them and just how to approach the question. If you want to have a look at every single circle theorem, how to tackle every type of question, you'll have to look at my circle theorems video. Now, some information to go along with this. I'm going to say that AP and BP are tangents. There we go. So when it comes to tangents, they meet at equal length. That's one of our circle theorems. So these 2 lines here are equal length, meaning that APB, that triangle there, is an isosceles, meaning that the base angles, these 2, are the same. So there we go, we can start to figure out some of the angles here, because if we do 180, the angles in a triangle, take away 86, it leaves us with 94. That we can split in half to share it between our 2 triangles there. So 94 divided by 2 is 47. So both the angles at the bottom of the triangle there are 47. There we go. And as with all these questions, it always says to state your reasons. So you would say tangents meet at equal length, therefore this triangle is an isosceles, okay, and writing that down. Okay, on to the next bit. We've also got, and it doesn't say it here, but O is the centre of the circle. Now O to B there is a radius, looking at this line just here. And a radius meets a tangent at 90 degrees, meaning, and always draw this on the diagram when you see a tangent meeting a radius, we've got a right angle just here. So we can work out the value of x, because if the full angle is 90, we're going to do 90, take away the 47, and that leaves us with 43 degrees. The important part with this question is to make sure you write down all those reasons. So we would write that tangents meet at equal length, isosceles base angles are the same, and then our final reason for this bit of the working out, the tangent meets the radius at 90 degrees, and therefore we could do 90 take away 47. Okay, a different circle theorem question with some different circle theorems within this one. So if you have a look, we've got these points A, D, C, B around the circle, and that forms a quadrilateral. And these are called the cyclic quadrilaterals. And the rule here is that opposite angles add up to 180. So we've got the 70 over there, so opposite that is the y. And opposite angles have to add up to 180, so we could do 180 take away 70. And it gives us our answer of 110 degrees. And our reason for that, which we would have to write down again, is that opposite angles in a cyclic quadrilateral add up to 180. The next one here is to find this angle x, and that's going to involve one of our other circle theorems. And when you've got these points made at the centre, I'm just having a look at points D and B, and I always do this with a little highlighter. But if I make this angle 70 here, I can also, from the same 2 points, make this angle here at a centre. And that's one of our other circle theorems. Angles at the centre are double angles made at the circumference from the same 2 points. So to work out angle x, and this first one we did was y, to work out angle x we would just do 70 times 2, double it, and that would give us 140 degrees. And again, that would be accompanied by the reason angles at the centre are double angles at the circumference when they're made from the same arc. So our two answers here are 110 degrees and 140. Again, just a few little bits of circle theorems there to be having a thinking about, and making sure that you are writing down all those reasons. That's absolutely crucial for these.
Okay, so when looking at the volume of a composite shape, there's lots of shapes that we could have. But specifically, if we're looking at a composite shape, when looking at volume, we're going to be looking at that cross-section. And that cross-section of the shape is going to be made out of two different shapes. So the cross-section on this shape is this particular one just here, which has 5 sides. So in order to figure out the area of that, the area of the cross-section, we're going to have to split it up into different shapes. And of course, there's lots of different ways to do that. You could split it going down this way to make a rectangle and a trapezium. You could split it going across this way to make a rectangle and a trapezium. And of course, you could split it in lots of different ways to make 2 rectangles and a triangle, if that's something that you prefer. Now, whichever method you choose, I'm going to go with that first one, splitting it down the top. We just need to be careful to get all the correct lengths on that particular 2D face, just to make sure that we get the correct area. So if I draw that to the side, and absolutely fine for you to do this as part of your working out, I'm going to split it up so I can see all the lengths. So we have a height of 8, we've got a little width of 3 up there, we've got 3 over here, and the rest we're going to have to split ourselves. So obviously the height over here is also 8, this is also 3, and because that base length down there is 8, this would be 5. So if we go about working out the area of each of those, the rectangle on the left is going to be 3 times 8, so that's going to have an area of 24. Then we've got a trapezium on the right. Now the area of a trapezium is add together the parallel sides, so 8 plus 3, divide that by 2, and then multiply that by the distance between them. So we're going to multiply that by 5. Now if we work that out, and you can type that in on your calculator, we get 27.5. So adding those together would give us the overall area, and if we work that out as well, 24 add 27.5 is going to equal 51.5. So that's the area of the cross-section. Now we have the area of the cross-section, just like any 3D prism, we multiply it by the depth or the distance that that cross-section goes through the shape, which in this case is 12. So to finish this question off, we'd take the area of the cross-section, 51.5, multiply it by the depth of 12, and that gives us an overall volume of 618 centimetres cubed. And that would be our final answer for the area, for the volume of this composite prism that we have here.
Okay, so we're going to have to work out some missing lengths in this triangle. Now it's not a right angled triangle, so to find missing lengths and angles we can use either the sine rule or the cosine rule. And these are rules that you're going to have to remember. But we're going to have a look at one to start with and how we know when to use it. Now the first thing you do is you try and identify in a triangle for first of all what we're looking for, which is AB. So let's label that X. Now what I look for straight away is, do I have pairs of opposites? So I have this pair of opposites here, and I've got both of those. And then I've also got X opposite to this angle. So I don't have X, but it's in one of my pairs of opposites. So when we've got this scenario where there's 2 pairs of opposites, we can use the sine rule. And we only ever need part of the sine rule, so I'm just going to use A over sine A equals B over sine B. Also equals C over sine C, but we only ever need to use 2 of them here. So let's have a look. We need to label this up. Now I'm going to completely ignore the letters that are on the actual triangle itself. I'm going to label this angle A, which it already is, and this side little a opposite that, and then this angle B, and the one opposite little b. And all I need to do now is stick all the numbers into the formula. So let's have a look. A is 12, so it's 12 over sine the one opposite that, 55, is equal to b, which is our x, over sine b. Obviously you should already know there's two variations of this formula. We could have it flipped over, so we could have sine A over A equals sine B over B, but this is our one for side lengths, and we know that because our unknown piece is on the top, so we're able to isolate this now quite easily. So, sorry, I've written B there, it should be 20. There we go, sorry, there we are, 20. So all we need to do is times both sides now by sine 20. What you could do is work this out on your calculator and times your answer by sine 20, but I'm going to multiply it straight over so I can type it all in one go. So times by sine 20, And if we do that, we get 12 sine 20, it goes onto the top there, over sine 55. There we go. And all we have to do is type that into your calculator, obviously just being careful that you put these angles in brackets. Some calculators are going to need you to do that. So if we type that all into the calculator, again, not forgetting you could just work out 12 over sine 55 first, and then times it by sine 20, but I'm just going to go for it like this. So 12 sine 20 on the top, closing your bracket, over sine 55. And on your calculator, just writing down what you got 5.01033939998. Now a question would normally say how to round this, so if we imagine it was 2 decimal places for this one, it would be 5.01, and it's a length, so centimetres. Okay, so just obviously just be careful what the question says. Let's have a look at an idea where we've got to find the angle. Okay, so in this question, let's have a look. Work out the size of angle BAC. So let's identify that. That is here, BAC. Okay, so we're going to use the formula the other way around this time. So sine A over A equals sine B. That does not say sine B. Sine B over B. Okay, so plugging in our numbers, let's just label it up. So let's call this one A, as the A is next to it, that's fine. And again, I'm just going to write over this one, I'm just going to put B and B. Okay, just because of the way I've written my formula. So then sticking in all the numbers, what have we got? Sine A is sine X, so we have sine X over 20, equaling sine 43 over 14. Okay, so exactly the same approach as we did before. We can isolate the sine X by timesing both sides by 20. And again, you could work that right hand side out and times it by 20, but I'm just going to go stick it up the top there. So we end up with sine X equals 20 sine 43 over 14. And if we type that into the calculator now, what do we get? 20 sine 43 over 14, and we get an answer here. Let's write it over here. So we get sine X equals 0.97428 and a few more decimals. And obviously, just like normal trigonometry when you're doing SOHCAHTOA, to get the actual X here, we have to do the inverse of sine. So we're leaving that number on your calculator. You do shift sine, which gets you sine minus 1. Type in that answer or just press your answer button. So shift sine, answer, press equals, and I get an answer here of 76.9779. And again, a question would ask us to round it here. Just depends. So let's just go to the nearest degree. We go for 77 degrees. Obviously just making sure what the question says here, but let's just round it to the nearest degree there, so 77. Okay, so that's how you use the sine rule. Right, let's see how this question's different then. So work out the length of AB. So this one over here. Now straight away, looking at this, look, we've got a pair of opposites there, but I don't have any other pairs of opposites. I've not got anything opposite my 15, I've not got anything opposite the 12. So I can't actually use the sine rule here, and that is your clue, that is your hint here, that the sine rule's not going to work, and we're going to have to use the cosine rule. So another rule that you need to know, so the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Okay, so a being the side we're looking for, so we'll label this little a and this one big A, ignoring the letters on the triangle, and then labelling the other two sides, and they can be B and C, however you like. And from there, all you've got to do is stick these numbers in. It's actually quite simple to use when you know it. So a squared equals b squared, which is 15 squared, plus c squared, which is 12 squared, minus, and I'm going to stick this bit in brackets, 2 times 15 times 12 cos a, which is down here, which is 20. There we go. Right, so sticking that all in the calculator, let's have a look what we get. So 15 squared plus 12 squared minus 2 times 15 times 12 cos 20. Press equals, and I get a squared equals 30.7106 and a few more decimals. Now obviously that is a squared, and we don't want a squared, we want to know what a is, so we just need to square root both sides now. So square root, leaving the answer on your calculator, square root answer, and we get a equals 5.54 1719. And again, obviously you'd be asked to round this in a particular way in the question. Let's go for 2 decimal places, so A equals 5.54 centimetres. Right, there we go. And there's using a bit of the cosine rule. Okay, so working out the size of angle BAC, which again is this one at the top. And again, just having a look, there are definitely no opposites because we've got no other angles. But the angle that we're looking for is going to be our A, and it is opposite 9. There we go, so the others can be B and C again. Now, obviously here we're looking for an angle, so it's up to you if you choose to learn the formula. I tend to find that I just learn this formula, A squared equals B squared plus C squared minus 2BC cos A. And then I'm quite happy just rearranging that to get cos A on its own. So in order to do that, I'm going to get this whole minus 2BC cos A. I'm going to add it to the other side. So we get A squared plus 2BC cos A equals B squared plus C squared. Now I can get rid of that A squared, so we can minus A squared from both sides, so minus A squared, and you get 2BC cos A equals B squared plus C squared minus A squared now. And now you can finish off this rearrangement. You can divide by 2BC just to leave you with cos A. So cos A equals B squared plus C squared minus A squared over 2BC. It's up to you. You can choose to just learn that formula if you want, but that's the formula we're going to use to find an angle. So plugging in all these numbers then just into my formula there, we'll get cos A equals B squared plus C squared, so 10 squared plus 5 squared, minus A squared, so minus 9 squared, all over 2 times B times C, so 2 times 10 times 5. Nice and easy typing that into the calculator, so fraction button, 10 squared plus 5 squared, minus 9 squared, all over 2 times 10 times 5. And that equals, let's have a look, so cos A equals 0.44, and then same process again, we need to do the inverse of cos, so cos minus 1 of your answer, and you get, let's have a look, shift cos, answer, and I get 63.896, there we go, degrees. And again, we could round that, so we could just say 63 point, and let's just go to 1 decimal place, 63.9 degrees. Again, just reading the question. And that's how to use the cosine rule for finding angles. Okay, so we're going to have a look at some statistics. This is going to be quite a short one. We've only got a few questions to have a look at, and we're going to start with a box plot. So on here, we've been given some information about some time in seconds that 15 people wait to be served at a garden centre, and it wants us to draw a box plot for this part A. So we've been given a list of numbers for those minutes, and you've just got to make sure that they're in order, because we need to find a few values. We need to find the lowest value, the highest value, the median, and the 2 quartiles, the lower and upper quartile. So we can quite easily see that they are in order, so we can get the lowest and the highest value from either side, and they're going to form the ends of our box plot. So just very carefully on your scale here, drawing the ends in here, and 44, just make sure the scale goes up in ones. It does. I'm going to do it as best as I can here, and that's our 44 there. Now we need to find the median. So with 15 people, we just want to find where that halfway point is. So what you've got to do is add 1 and halve it. So 15 plus 1 is 16, divide it by 2, and that's going to be our 8th person. So we just need to go along the box plot and find where the 8th person is. So 1, 2, 3, 4, 5, 6, 7, 8. So 25 is going to be our median. That's quite nice. It's halfway between 20 and 30. Draw an end nice and neat there to form our median. Now we just need to find where the quartiles are. So on that lower half, okay, the lower part or the lower quarter here, if I try and highlight that, we've got these numbers here, and there are 7 numbers there if you just count them up. So 1, 2, 3, 4, 5, 6, 7. So again, finding the halfway point, we can do 7 plus 1 and divide it by 2, which gives us 4. So we want to find where the 4th person is for that lower quartile. So 5, 9, 11, 14. There is our lower quarter there. So marking that on the 14th person. 1, 2, 3, 4. And then looking at the higher quarter there. 27, 27, 28, 30. Okay, so once you've marked all of those on there, you've got to join up your little box. There we go, making it look like the one that you can see below, and then join up these parts here, and there's your box plot drawn. Okay, moving on to the bit below. Now I haven't added the question in here, but quite often it says to compare the box plots. So it says here, the box plot below shows the distribution of times served at a different garden centre. And it would usually say to compare them. Now, there are two things that you want to compare when you're comparing a box plot. One of them is the median. So if we have a look, our median here is sitting on 25, and down it's sitting here on 21. Now I don't have to mention any numbers, but I would mention number 1. I would say that rows, I'll just call it rows. Rows has a higher median wait time. Okay, so a higher median wait time. Okay, make sure that you mention some context. Obviously, don't just say it has a higher median. What's the story actually about? It's about the wait time at a garden centre. So rows has a higher median wait time. The next thing we have a look at is the distance between the quartiles. And again, I don't have to mention any numbers, but I just have to think, this is the distance between the quartiles. It's called the interquartile range. And on the one below, here is the distance. Now hopefully you can see there visually that on the Greens Garden Centre there is a higher interquartile range, meaning that the data is more spread out, and you want to mention that word spread out. So number 2, my comparison here, Greens has a higher, I'm going to abbreviate it to IQR, interquartile range, meaning the data is more spread out, or meaning the wait times are more spread out. There you go, more spread out, and mention that word there, spread. There you go, so more spread out, and that is drawing a box plot and also making a comparison between the two. Let's move on to our next one. Okay, and looking at some ratio and proportion now. So this says James has a bag full of counters. He takes at random a sample of 20 counters, marks them all and puts them back into the bag, and then he takes 30 counters at random, and out of the 35 of them are marked. Estimate how many counters are in the bag. So we're looking at capture-recapture here. Now if we just make a few statements, because we're going to assume that the sample is proportional to the next one that he took as well, or to the rest of the counters in the bag. So initially, he takes a sample of 20 counters out of, we don't know. That's what we're trying to work out, so let's call that 20 over x. On the next time, he takes a sample of 30 and 5 of them are marked. So we'll say that that's now 5 out of 30. So out of the 35 were marked, but previously it was 20 that were marked out of something we don't know. But we are going to assume that these are proportional. So in order to work out how many that x value is, we just have to think, okay, well, how do we get from 5 to 20? And we do that if these fractions are equivalent by multiplying by 4. So in order to get that number on the bottom there, we would multiply this by 4, and that would give us 120. So our answer would be 120 counters. Okay, obviously we are making some assumptions here. We are assuming that no additional counters were added to the bag in between the two samples, and also none were taken out as well. And obviously there's little silly things like we're assuming that the marks haven't actually come off the counters or anything like that in this time frame. Okay, so that is capture-recapture there. The next one, we've got a lot of information here. So it says Sophia asked 50 people which drinks they like best from tea, coffee and milk, and all 50 people that she asked liked at least one of the drinks. Then it starts to talk about all these different ideas about what drinks people liked and whether they liked all three, whether they liked tea and coffee. So we're going to go through all of them there, but ultimately it says she selects at random one of the 50 people, work out the probability that this person likes tea. So we need to figure out from all this information how many of the people there like tea, and it doesn't explicitly tell us how many like tea. So when we've got these three options like this, the best way for us to organise this is in a Venn diagram, and specifically a three-way Venn diagram. So we need to draw, I'll do this as best as I can, a Venn diagram that's going to allow us to have three elements in there, and you just need to make sure with a Venn diagram you draw your little box around the outside. There we go. Now I want to keep this all nice and neat and tidy, so I'm going to label them. I'm going to call this one the milk, this one the tea, and this one down here the coffee. I'm just going to go through the list and just start to tick things in when I know that I've got them there. Now the first piece of information it tells us, and if we go through this step by step, it says all 50 people like at least one drink. So that means we know that there's going to be nobody in the outside, so 0 on the outside. Next thing we've got is 19 people like all three drinks, and that's a key piece of information there because we can definitely put that in straight away. The people that like the all three are right smack bang in the middle there, so we've got 19 in the middle. So we've dealt with that one, and you can tick them off as you go or highlight them. So that next one says, it says 16 people, I'm going to swap to a different colour here. It says 16 people like tea and coffee, but don't like milk. So the people that like tea and coffee are going to be in the crossover between the T and the C circles, but they do not like milk, so that's fine. We can put them in there, 16 that like tea and coffee, but do not like milk. There we go. Tea and coffee, but don't like milk. It then says 21 people. Let's try swap to another colour. 21 people like coffee and milk. Oh, I'm just going to get rid of that because I've got too many things going in there. I've got 21 people like coffee and milk. So 21 people that like coffee and milk. Well, let's have a look. Coffee and milk is this crossover here, but also includes that 19. It doesn't say 21 people like coffee and milk but don't like tea. So if 21 people like coffee and milk, well, we've already got 19 in there that like coffee and milk, so that's going to be an extra 2 that makes that up to 21 there in that little crossover with coffee and milk. 19 of them also like tea, but then 21 in total like coffee and milk. So that's that one dealt with. How many have we done now? We've done all 4 of those. There's lots on here. On to the next one. We've got 24 people like tea and milk. So 24 people like tea and milk. Let's have a look. Well, tea and milk is this one here. But again, it doesn't say that they don't like coffee. So 24 people like tea and milk. 19 are already in there. So that's going to be an additional 5 people there. And that makes up 19 and 5. That's 24 people in total that like tea and milk. On to the next one. We've got 40 people that like coffee. We've already got 3 people in our coffee circle there. We've got the 2, we've got the 19, and we've got the 16. So in total that adds up to, let's have a look, 2 plus 19 is 21, add the 16 is 37, and it says 40 people like coffee, so that's going to be an extra 3 that make that coffee circle up to 40. Next one, this one's a nice easy one to finish. We've got 1 person likes only milk. So in the milk we've got 1 person, and then we're given no more information. But there is this missing number here in the T. Now just remember, it did say in the question that she has 50 people. So if we add up all the numbers we've got 1 plus 5 plus 2 plus 19 plus 16 plus 3. And all of that adds up to make 46. And in total we have to have 50 people in our Venn diagram. So just in the T one there, that's an additional 4 people to make sure that we have 50. So we just did 50, take away 46, which left us with those remaining 4 people. So we filled in our Venn diagram. Now it says, Sophia selects at random one of the 50 people, work out the probability that this person likes tea. Well, that doesn't say just likes tea, it says the probability that they like tea. So we've got a few of the numbers here that we can actually consider. We've got the 4, the 5, the 19 and the 16. So the amount of people that like tea, if we add them all together, 5 plus 4 is 9, plus the 19 is 28, plus the 16, what does that give us? 19 plus 16 plus 5 plus 4 gives us a total of 44 people that like tea. So there's 44 people that like tea out of a total of 50 people, so it's 44 out of 50. 44 of those 50 people like tea, and the rest don't like tea. You've got the 1 person that only likes milk, you've got the 2 people that like milk and coffee, and the 3 people that only like coffee. So 44 over 50, and you don't need to simplify that. And that's our Venn diagram done. Just make sure you go through and tick them all off as you go so you haven't missed any. Let's have a look at another one of these. Okay, so this Venn diagram is a little bit more complicated. It says 82 students were asked what their favourite fruits were. 39 like apples, 50 like bananas, 39 for oranges, 21 like apple and bananas, 18 like bananas and oranges. And we've got some more information there, but the one we're looking for is the amount of people that like all of them, and this doesn't actually tell us the amount of people that like all of them. So we're going to have to take a little bit of a different approach here, but it does say how many of the students like apples and oranges but not bananas, so we're going to look for those people in a sec. Now if I draw a little Venn diagram for this one again, I'm going to need a little bit more space. I might actually make that a little bit bigger. Let's make this one a bit bigger. Okay, so we've got our Venn diagram, again, nice little box on the outside, and let's have a look at what needs to go in here. So 82 students were asked what their favourite fruits were, so we know that 82 people are going to have to go into our Venn diagram. Now it says that we've got lots of different bits of information, haven't we, here? So let's just label it up so we can keep it nice and clear. Apples, bananas, and oranges down here, not to mistake that for 0 people there, that's oranges. Now we don't know how many people are in the middle, so we're going to apply a little bit of algebra here. I'm going to say, okay, well there is an amount of people in the middle, and we'll call that x. Now we can start to have a look at some of the other bits of information. I'm going to disregard the apples, bananas and oranges bit to start with, but what I am going to do is just label that up here just so I remember. So apples is 39, so we know 39 in total in that circle. Bananas is 50, so we know there's a total of 50 going into that circle. And oranges is 39, so we know there's a total of 39 going into the oranges there. Okay, so I'm going to tick those all off. I've drawn them on my Venn diagram, I'll remember that later. Now it says, there we go, 21 liked apples and bananas. So 21 like apples and bananas. So that is going to be 21 in total, including that crossover that's going in these two, just here where the apples and bananas cross over. So if I knew what the middle number was there, I'd do 21, I'd take away the value of x in the middle, but I don't actually know what x is, so I'm just going to write in here that's 21 minus x for that one. Okay, so that's that one done for the moment in terms of algebra. Then we've got 18 that like bananas and oranges. So bananas and oranges is just here, but again we don't know what that middle one is there. It doesn't say that they like bananas and oranges but not apples, so that's going to be 18, take away the middle number, which again is x, 18 minus x. Onto that last one, we've done this one now. So 19 liked apples and oranges, and again that's this one here, apples and oranges, but again we don't know the middle number, so we'll call that 19 minus x. There we go. So there's our bits of algebra. Let's tick that off. And then it says 22 like exactly 2 of the fruits. Now the people that liked exactly 2 of the fruits are the first one we did, 21 minus x that like apples and bananas. We've got 18 minus x that like bananas and oranges, and we've got 19 minus x that like apples and oranges. So what we can actually do is we can create a bit of an equation here. Now if we add those all together, that has to equal 22, because it says 22 here like exactly 2 of the fruits. So if we add them all up, let's have a look, let's just add them all up. We've got 21 minus x, we've got 19 minus x, and we've got 18 minus x. And if we add them all together, let's see what we get. So 18 plus 19 plus 21 gives us a total of 58. So we have 58 minus 3x's, so minus 3x. So actually we can create a bit of an equation here. I'm running out of space a little bit, so I'm going to do it over here. But we have this equation, we've got 58 minus 3x, and it says it has to equal 22 people. So actually we can just go about solving this now. So actually what I can do, and we can rearrange it if we like, but I'm just going to minus 58 from both sides. So 22 minus 58 gives us negative 36. So we have negative 3x equals negative 36. And if we do negative 36 and divide it by negative 3, that gives us a value of x, which is 12. So we know that x, that one in the middle now, has to be 12. So actually what we can do, we can start to get rid of some of these numbers and actually, get rid of some of these x's and replace them with numbers. So if I get rid of the x in the middle, and we'll replace that with the 12, because we now know that 12 is in the middle. We can then do 21 minus x above that, which leaves us with 9. So we can get rid of 21 minus x. Oh dear, got rid of the whole circle there. We can get rid of 21 minus x, and we can just put 21 minus 12, which is 9. So there's 9 going in there. We can get rid of 19 minus x. 19 minus 12 leave us with 7. So we can get rid of that. We just got 7 in there. And then we've got 18 minus x on the right there, and 18 minus 12 leaves us with 6. So we can have 6 in there. There we go, 6. Now we might be able to answer the question from here, but let's go ahead and fill in the rest of the Venn diagram as well. So we know that in A, there's 39 in total, and we've got 9, 12 and 7 that's already in there, and 9 plus 12 plus 7 is 28. So we need an extra 11 in the apples there to make it up to 39. Moving on to the bananas, again we've got 9, 12 and 6, and 9 plus 12 plus 6 is 27. We want to get to 50, so that's an extra 23. And then in the bottom one, we've got 7 plus 12 plus 6, adding up to 25. We need 39 in there down the bottom, so that's going to be an additional 14. Right, there we go. So that's our Venn diagram filled in. Now the question said, not to forget what it was actually asking us here, it said how many of the students like apples and oranges but not bananas? Now the ones that like apples and oranges but not bananas are here. Let's highlight it. These ones here like apples and oranges, but they don't like bananas. So we've got 7 people there. So we've got a total of 7 people out of the 82 people in total, and that will be our final answer. There we go. So you can apply this to a Venn diagram that's not a triple Venn diagram where you've just got a normal 2 two-circle Venn diagram as well, but when it doesn't give you that crossover number there, you do have to think about how you can apply algebra to this, so that's quite a complicated one there, but just a little example of how you can approach some of these harder Venn diagram questions.
If you're only going to watch one video this year, this is the one. With GCSE Maths right around the corner, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1. Head to the TGMT hub, go to the bottom of the page once you've logged in and access the revision quiz. From here you can answer a question on every topic within the GCSE. You can go through working through each question and making sure that you practice absolutely everything. Once you've done that, you are going to get a full report that shows you exactly what you got right and wrong on all of these questions. So work your way through the quiz and then access your report. From here you can see on individual units what you need to work on and what you've already secured. So identify what you need to work on. Then we're on to step 2. Head back to the hub. You can go through the units, you can go to the exact one that you know that you need to work on, and you can access all the individual topics within that unit. Once you've done that, you can pick the topics that you want to work on, watch the video, and you can complete a topic quiz for that particular topic. So work your way through the quiz, answer those questions, and then you're going to get another report. That's going to show you exactly what you got right and wrong, so that you know if you need to do any more work. Step 3. Head back to the hub and go to the bottom. You can now go onto the upgrade quiz. On here, you're going to be able to answer questions again, different to the first, on every single topic within the GCSE. Once you've done that, you're going to get another quiz breakdown and a report that shows you exactly what you got right and wrong, so you can put any of those finishing touches in before that exam comes along. With the exams right around the corner, we need to make sure that we make revision simple. Join Upgrade. Okay, so when multiplying fractions, we first need to make them improper fractions if they're mixed numbers. So if we look at this fraction calculation that we have here, we've got 1 3/4. So 1 times 4, add the 3 would give us 7/4. And then for the other one, 1 times 3, and add the 1 would give us 4/3. Now we're multiplying these, which is nice and easy. We just need to multiply the top, which would give us 28, and multiply the bottom, which gives us 12. Now it says in this question to give your answer as a mixed number. So we're going to want to go about simplifying this and seeing how many times 12 goes into 28. So 12 fits into 28 twice, and there would be a remainder from 24 to 28, so there'd be a remainder of 4. So we'd have 4/12 left over. Now whenever we give fractional answers, we never give them like this without this fraction here being fully simplified, so you do need to check to see if that simplifies. This particular one, the numerator and denominator both divide by 4. So we'd divide those both by 4 and we'd get a final answer of 2 and 1/3. And that'd be our final answer there, given our answer as a mixed number and making sure that that little fraction there is fully simplified.
Okay, slightly higher number, expressing 180 as a product of prime factors. When a number ends in a 0, just personal preference, I always like to divide that by 10, so I'd go for 18 and 10. But again, you could go for 2 and 90 and just try breaking it down that way. But I like to go for 18 and 10 because now both these numbers are relatively small. So neither of those are prime. Again, if it helps, just make sure you write down some of the prime numbers. There we go. So 18 is 2 times 9, 2 being prime, but I'm just going to keep going. 9 is 3 times 3. And then 10 is 2 times 5. Now if I'm happy that they're all prime, which I am, 2 and 2, they're definitely prime. 3 and 3, they're prime, and 5 is prime. So writing these out as a product of prime factors. Now if I read them from left to right, it's 2, 3, 3, 2, 5. Now it's personal preference for me, but I like to write them all in size order and group the numbers together. So 2 times 2, times the 2 3s, times the 5. Okay, and now we can write it in index form. So we've got 2 2s, which is 2 squared. We've got the 2 3s, which is 3 squared. And we've got the 5 at the end. And there's our answer as a product of prime factors in index form.
Now this question says find the value of the reciprocal of 1.6 and give your answer as a decimal. Now when it comes to doing reciprocals, it's much easier to write the number as a fraction. So straight away, let's write 1.6 as a fraction. Now to do that, we've got the 1, which is fine, just like a normal fraction, and then we've got a 0.6. So 0.6 is the same as 6/10, so it's 1 6/10. Now we probably want to simplify that just to make it all a bit easier. So if we simplify it first, we could write that as 1 and dividing both the numerator and denominator by 2 would give us 3 over 5. So we need to find the reciprocal of 1 3/5. Now to do that, we'll quickly make that an improper fraction. So 1 times the 5, add the 3, would give us 8/5, and then turning it into a reciprocal, or doing the reciprocal, is literally just flipping it over, so it becomes 5 over 8. Now this particular question has said to write your answer as a decimal. So if we just type that in on our calculator, 5 divided by 8 comes out as 0.625. And there we go. There is the reciprocal of 1.6. It came out as 5 over 8, which as a decimal is just 5 divided by 8, which is 0.625.
Now there's quite a good little trick for all of these little questions, so I'll explain it a little bit in this first one, but then we are just going to be applying a little bit of a trick for the rest of them because they are quite nice and simple once you've got the hang of these. But having a look at this one, it says 32.7 has been rounded to 1 decimal place right down the error interval. So the error interval just means essentially if it has been rounded to 1 decimal place, what's the biggest and what's the smallest that number actually could have been. We refer to that, we use the language upper and lower bound. Okay, so we're going to have a look at what the upper and lower bound is. Essentially what's the upper bound is the biggest number it could have been, and the lower bound is the lowest number it could have been as well. So thinking about the number 32.7, and I'm only going to do this for this one question, but if we think about a little number line, so if I just imagine a number line, and here's 32.7 on my number line. Now the next 1 decimal place value above and below would be 32.8 and 32.6. Now thinking about this, if the number rounded to 32.7, then it could only be within these little sections here. It could be halfway between 32.6 and 32.7, or it could have been, and we'll talk about the upper bound, halfway between 32.7 and 32.8. Now those numbers in between 32.6 and 32.7 is 32.65, and in between 32.7 and 32.8 is 32.75. Okay, and it can sometimes help just adding a naught onto the end of these if it helps to sort of visualise that. So we can say in between 32.60 and 32.70 is 32.65. That can just help just to sort of visualise it a little bit better. Now in terms of the upper and lower bound, it could have been this number here, 32.65. Now 32.65, if we round that to 1 decimal place, does round to 32.7 or 32.70. But if you think about 32.75, this one here, it can't actually be that number, can it? Because that would round to 32.8. Think about our rules of rounding there. That 5 at the end would round it up to 32.8. Okay, but we're going to incorporate that into our error interval. So when we write our error interval, and it's going to be these two numbers here, okay, this one here is called our lower bound, and the upper one there is called our upper bound. Okay, but when we put this into our error interval, we're going to incorporate the fact that it couldn't actually be equal to that upper bound there. Now when we write our error interval, it looks a very specific way. We put something in the middle. We can either put 32.7 or we can just put a letter in the middle. I'm just going to put the letter X in the middle. We have 2 arrows pointing to the left for our inequality here. This is how we write it. And we put our lower bound on the left and our upper bound on the right. So our lower bound on the left, signifying our lower number, is 32.65. And our upper bound on the right is 32.75. Now we just spoke about the fact that it can be equal to 31.65. So on our inequality for that one, we put the equal to symbol underneath the inequality there. But it can't be equal to 32.75, so we don't have a little equal to symbol on that inequality. So that right there is our final answer. And that means, as an inequality, it means that our number for 32.7 has to be somewhere in between 32.65 and 32.75. But it can be equal to 32.65, but it cannot be equal to 32.75. It's got to be less than that, because as soon as it hits 75, it would round up. Now that's the logic behind why we write the inequality the way we do, why we write this error interval like that. But there is just a nice little trick. Now if you look at this original number, 32.7, to get the upper bound, the only thing that's changed is this extra 5 on the end. And that's going to always be the case for these ones. All you have to do is put a 5 on the end. And then if you look at the lower bound, again there's a 5 on the end, just here, but the 7 has dropped down to a 6. So when I'm doing these, and I'm going to do it on the next ones, I find the upper bound, I just stick a 5 on the end, so 32.75, and then I also then do the lower bound, and I drop the 7 down by 1, or whatever number's at the end there, drop it down by 1, and again just stick a 5 on the end. So I'm going to do that on the next question, but there's a bit of an explanation as to why we do it the way we do. But once you've got your head around this concept here of just sticking a 5 on the end and then dropping it down for the lower bound with a 5, you can actually do these pretty quick. You've just got to remember the way that the arrows point both to the left. You can always think about a little song there that might remind you to always put them to the left, and then the equal to symbol always goes on a lower bound there. Just thinking about the logic behind why it can be equal to that one, it can't be equal to the upper one. Okay, let's have a look at another question. Okay, so here's this one. 340 has been rounded to two significant figures right down the error interval. Now again, when it comes to these significant figure ones, two significant figures in this case could have been described in a different way again. So not in terms of decimal places this time, but if you look at the number 340, that has been rounded to the nearest 10. Okay, so it's been rounded to the nearest 10, and just thinking about it like that can actually help in this case. So I'm just going to write here nearest 10. That's the other way that we could have described two significant figures. Now again, there is a little trick here. We'll think about the logic behind it, but in terms of the nearest 10, well, if we think about a little number line again, I'm not going to do this for any others, but if we think about a little number line, 340, 350 would be the next nearest 10, and 330 would be the next nearest 10 below. And in between those, again for our lower bound and our upper bound, it'd be 335 in between 330 and 340, and it'd be 345 in between the upper bounds there, okay, the 340 and the 350. So in terms of actually getting these, I mean, that is our lower and upper bound there. We've got 335 and 345, but thinking about the little trick, if it's to the nearest 10, that means it could be 5 above and 5 below. And the little trick for this one is just the first 0 that you see, that is going to become our 5 this time. Rather than just sticking a 5 at the end, it's our 0. So if I put 340 in the middle, okay, and I'll just show you what I mean here. So in terms of the upper bound, which I always do first, the first 0 in this case is what becomes our 5. So it's 345. And then the same process as before, the number before that drops down. So the 4 drops down to a 3, so 330, and stick a 5 on the end, so 335. Okay, and you can see that from our number line, but I'm just thinking about how you can do these nice and quick without fully drawing out a number line. Okay, so it's been rounded to the nearest 10. When it's significant figures and there's no decimals involved, there's a slightly different trick here. So the first 0 turns into the 5 for the upper bound, and then same process again, drop the number before it down and add a 5 on. Okay, so a very similar question. It says R equals V over I, and again, you probably recognise some of these formulas from your physics or your papers, but let's have a look. V equals 43.52, correct to 2 decimal places, and I equals 5.437, correct to 3 decimal places, and this time work out the upper bound for R. Okay, and give your answer to 3 decimal places, and we'll deal with that at the end. Now, first things first, obviously, again, we've seen the words rounded to 2 decimal places, so we'll write down our error intervals. And again, you can put the number in the middle here, but I just tend to write the letter X, and I've just got into the habit of doing it. So for the upper bound, we get 43.52 and stick a 5 on the end. And then for the lower bound, we get 43.5, drop it down to a 1, and again, stick a 5 on the end. And then for our other number that's been rounded, let's write our error interval for that. So stick a 5 on the end for the upper bound, 5.4375. And for the lower one, 5.43, drop the 7 to a 6, and stick a 5 on the end. And there we go, there's our upper and lower bounds of V and I. Now, this time it wants us to get the upper bound. So thinking about the logic from last time, in order to get the biggest possible answer, we want the biggest number on top. So we're going to want the upper bound of V on the top, the biggest number on top, and on the bottom we want to divide by the smallest possible number, so the lower bound of I. And again, you can test out different numbers here. You can test out all the lower bound, the number itself, and the upper bound on the bottom. You can see you will get the biggest answer using these digits here, so feel free to try them all out. But you will see, obviously, this is the quickest way of getting your upper bound here, because the other way of doing it is to test out all the different possible combinations until you get the biggest answer. But this is obviously just going to give you the biggest answer straight away, so having this little bit of knowledge is going to save you a lot of time. So let's find these numbers. The upper bound of V is 43.525, and the lower bound of I is this number here, 5.4365. So let's just plug those in. So 43.525, all divided by 5.4365. And let's type that into a calculator. So 43.525 all over 5.4365. And turn that into a decimal, you get 8.006070082. There we go, lots of decimals there. And we are going to then round this, as it says, to 3 decimal places. So the third decimal is the 6, so chop it after the 6. It's a 0 after the 6, so it's not going to change. It's just going to be 8.006. And there we go, there's our final answer to 3 decimal places. Okay, so a train takes 3 hours to complete a journey, correct to the nearest 5 minutes. The length of the journey is 260 miles, correct to the nearest 10 miles. By considering bounds, work out the average speed of the train. Give a reason for your answer. Now this isn't very nice, it's not a nice question at all, there's a lot going on here. Our first thing is that we have to work out speed. So our formula for speed equals distance divided by time. Okay, so we have to write down the formula for this one, so obviously it requires you to know that. Now we've got our fraction scenario going on, and we've got different elements going on in the question here. So we've got the distance, which is the length here, so we've got 260 miles. Let's highlight that, that's our distance. And we've also been given a time, so 3 hours, and that's to the nearest 5 minutes. So if we actually start to write these down, let's do the error interval of D, so for the distance. Right, so I'm going to put D there just to remind myself that's the one. So the distance there is 260 to the nearest 10. Now when it's to the nearest 10, remember that's the same as 2 significant figures in this time. So to the nearest 10 could be 5 miles above and 5 miles below. So our upper bound is 265. And our lower bound is 255. Again, do make sure you check out that video on error intervals if you're unsure on this one. But 255 and 265 are my bounds for the distance. Now I'm going to have a look at the error interval for the time. Now this is quite a nasty one here, okay, because it's given us the time in hours and it's given us the error interval in minutes, and it says the nearest 5 minutes. So in order to get this, let's turn 3 hours into minutes. So 3 hours into minutes is 3 times 60, 60 minutes in an hour, which is 180 minutes. So the time it takes is 180 minutes. Now it's to the nearest 5. Now remember, to get the upper and lower bound to the nearest 5, you add 2.5 on and take away 2.5 minutes for the lower one. So 180 add 2.5 becomes 182.5. And taking 2.5 away would become 177.5. Okay, so just be very careful when you're adding 2.5 and taking 2.5 away there. Now that's not going to be very nice, because we're typically going to want our answers in miles per hour. Now if we're going to do miles per hour, we need to turn this back into hours. So that's not particularly nasty, it's just that we have to remember to do this. So dividing them both by 60, we'll turn them back into miles per hour. And if we do that, 177.5 divided by 60, if I can type that in correctly, 177.5 divided by 60 doesn't give us the nicest of decimals, it gives us 2.958 and a recurring 3. But there we go, it's back into hours. And for the one at the end here, 182.5 divided by 60, again doesn't give us the nicest of decimals, it gives us 3.0416 with a recurring 6, there we go. And that is our time back into hours. That'd be okay if we could give our answer in miles per minute, we could just leave it in minutes, but in order to do this we do need our answer back into hours there. So now we've got our error intervals done, we still need to actually go about using this formula. So we've got speed is distance over time. Now let's move that out of the way, let's put that up here. Okay, and we're going to have a look at working this out. So to get our upper bound, which we can work out first, to get our upper bound, let's have a look. What do we do for upper bound? We do the distance upper bound, so the upper bound of D, and divide it by the lower bound of T, the time, which is there, 2.9583. So let's just write that in. That was the upper bound divided by the lower bound. Thinking about speed is distance over time. So we've got 265, and we need to divide that by 2.958 recurring 3. I'm going to write down what that actually equals. Okay, so In order to get that decimal, what I'm going to do on my calculator, I'm going to type in 177.5 divided by 60 again, so that I have that decimal on my calculator screen. Okay, I'm just talking about this one just here, so I didn't have to type it back in. And now I'm going to type in 265 divided by answer, so that it does, so I don't have to try and type in that recurring decimal. There we go. And if I type that in, we get 89.57746. And then we've got a few more decimals, 4788. I'm going to leave it there because it tends not to go beyond these. Again, if I find that it does, I'm just going to have to retype this all back in again. Hopefully it doesn't though. Now to work out the lower bound. So for the lower bound, that is not an L. There we go. To work out the lower bound, we've got to do the lower bound. That is not, for some reason I keep wanting to write in the upper bound. We have to do the lower bound and divide it by the upper bound. Okay, so picking those numbers out nice and carefully, we've got the lower bound of the distance, 255, divided by the upper bound of the speed of the time there. Right, and typing those in, what do we get? So the lower bound there is 255, divided by 3.0416. Right, and let's type that in. Right, let's get rid of this little miles per hour thing, I don't actually want that there. Right, so typing this into the calculator, and again what I'm going to do is I'm going to retype this calculation in here, 182.5 divided by 60, so I've got that decimal on my screen. So 182.5 divided by 60, so I've got 3.0146 recurring on my calculator, and now I can do 255 divided by answer. And I'm going to write that down, let's have a look, that gives me 83.83 561, and there's a recurring dot above the 8, but I can't write them all down. There we go. Okay, so let's have a look at this. Now this is a very bizarre one, because if you have a look already, you can already see that there's no amount of decimal places that are going around, because we've got 89.5 and we've got 83.8, so they are very far away from each other. So this is going to be a very, very bizarre question here. So if this scenario did arise, and you'd hope, and it is usually the case, that they are quite close together and they do round to a nice amount of decimals, but it could be absolutely anything. So for this particular question here, we are going to have to think about how we're going to round it. Now, even to one significant figure here, they don't round to the same amount. Well, that one on the top there rounds to 90, and the one on the bottom rounds to 80. So that's absolutely useless, so that's not going to work. So the only way that we could actually round this to the same is if we round it to the nearest 100. Okay, so the average speed, we're going to have to round to the nearest 100, which seems a bit odd because it's actually quite a distance away from that, but they both round to 100 to the nearest 100, and that is the most accurate that we could actually do this question. So I would have to say 100 miles per hour. There we go, and that would be to the nearest 100. There we go. Now, it's very rare that a question will do this, okay, because it just doesn't make for a very good question. But that's not to say that it can be ruled out, okay? It could actually happen. You could have a question like this where the only way it rounds is to the nearest 100 and it's quite a distance away. And if that does happen, then at least you know that you are able to do that. But to be honest, the majority of the questions do actually round to the nearest like decimal or significant figure or something like that. But that's not to say that it couldn't happen. So it's a good question, obviously, to bring up here. Obviously, if it does round to one of the decimals there, you've already done a few of those, so you know that you're absolutely fine to go about doing one of those questions.
Okay, so when we have a negative indice, the negative in the indice just represents a reciprocal, and a reciprocal is just where you flip over a fraction. So obviously 3 at the moment is not a fraction, but it could be written as 3 over 1. So to do a reciprocal of that, which is what that negative in the power means, we're just going to write it as 1 over 3. Now that has dealt with the minus there, and if it was 3 to the power of minus 1, this would be our answer. It'd just be 1 over 3, but this is 3 to the power of minus 2. So a number in the power as well just means now we have to do the normal power, and a normal power of 2 is just to square the numbers. So I just need to square both these numbers, and that would be my final answer. So on the top there, we've got 1 times 1, which is 1, and on the bottom, you've got 3 times 3, which is 9. So our final answer is just 1 over 9. Now, of course, when you've got negative powers, you can also have fractions involved in the power. We're going to have a look at a fractions example as well. And of course, The piece at the start, so in this case the number was 3, could also be a fraction, and in which case you just wouldn't have to write it as 3 over 1, you could just flip it over straight away. But let's have a look at one with a fraction involved.
So this first one, we've got 25 to the power of negative a half. Now when it comes to these powers, we just need to remember what each piece does. So if we make some notes on this, the negative part of the power, as we've seen before, does the reciprocal. It flips it over. So it flips it over. The number on the bottom, underneath that line there, which I like to refer to as ground level, the number underneath does the root. So in the case of a 2, that would be a square root, and if it was a 3, it'd be a cube root, and so on. And the number on the top is just a normal power. So these are the three things that we have to look at when we have these combinations going on. And sometimes we might not have a number on the bottom, sometimes we might not have a negative, but if we have them all, we have to think about all three of these pieces. So it doesn't matter what order you do it in. Now, I tend to always go for this number on the bottom first, purely because it's easier to do the root of a number than it is to then do the normal power when the number's quite large. If we imagine there was a normal power of 2 on the top, it'd be a lot easier for us to square root this than it would be to do, say, 25 squared first. So I always do the number on the bottom first. That's just personal preference, although you can do it in any order that you like. So what I've got to do here, first of all, I'm going to deal with this number on the bottom. So I'm going to go for this root first. So if I do the square root of 25, we get the answer 5. So that's the root dealt with. Now I'm going to move on to the other piece. So I've got the flip going on, or the reciprocal. So if I flip 5 over, remembering 5 is 5 over 1, if we flip that over, it becomes 1 over 5. Now the normal power there is just a 1, and a normal power of 1, let's find a different colour, I've used quite a lot now. A normal power of 1 doesn't actually change anything. Anything to the power of 1 is just itself. So that 1 over 5 there would be my final answer. Okay, so looks a little bit trickier, but we're going to take exactly the same approach. First things first, we're going to have to get rid of this divide by 3. So times both sides by 3, and that's going to give us a single line equation to look at. So the top doesn't change, we're just reversing that divide by 3, so 4x plus 1 equals, and then we're times in both of these by 3, so we get 6x minus 6. And then we're just going to treat this just like we did in the earlier questions. So get rid of the smallest value of x, which is the 4, so minus 4x. And that leaves us with 1 equals 2x minus 6. Then we can get the numbers on one side, so leave the 2x where it is. Let's add 6 to both sides. And we get 7 equals 2x. And then we can finish that off just like normal. We can divide by 2. And that leaves us with x equals 7 over 2. Which you can write as 3.5 or 3.5 if you want, but that's fine to leave your answer as a fraction there. It doesn't ask us to write it as a mixed number or anything. So there we go, 7 over 2 is our final answer. Now these are solved in a very similar way to solving equations, okay? But obviously it's not an equation, it's an inequality. It's got our inequality symbol rather than our equal to symbol. So we're going to have a look at actually finding a range of answers here rather than just one single solution. So when we've got a sort of an equation that says 3x minus 5 equals 7, we're finding the exact solution that actually gives us this value. Now this inequality in this question, this is going to run throughout the video, says 3x minus 5 is less than 7. So what we're actually doing is we're finding what values of x would obviously give us answers less than 7. And that's what we're actually finding here when we use this inequality symbol. But as I said, we're going to treat it in the same way as solving equations. Obviously, if you want to get yourselves clued up on solving equations, I'll try and link the video in the description for that, for solving linear equations when we've got an x on one side or on both sides. But we're going to do exactly the same process. So I'm going to assume that we have a good knowledge of solving equations before actually approaching this. So I'm not going to talk about all the ins and outs of how we solve equations, but I'm just going to show you that we're going to solve this in the same way. Now we'll come to actually drawing it on the number line in a sec. So before we get there, we need to actually solve this. So we've got a minus 5 on the left. Now obviously we want to isolate that x there. So I'm going to get rid of this minus 5 to start with. So if we add 5 to both sides, let's have a look what we get there. We get 3x, and that's going to be less than 7 add 5 is 12. So 3x has got to be less than 12. Now we can divide both sides by 3, obviously, because we want to know what 1x is less than, not what 3x is less than. So when we divide both sides by 3, we get x is less than 4, and that is our solution to this inequality here. X has got to be less than 4. Thinking about the logic behind this, look, if you actually put 4 into this equation up here, we would get 3 times 4, this inequality, sorry, I shouldn't say the word equation there. We get 3 times 4, which is 12, take away 5, and that would equal 7. Now, obviously, we want to know what's going to be less than 7, so what we found here is that as long as we put a number in less than 4, it's going to give us an answer there that's less than 7, and that's what we're looking for, which values of x are going to be less than 7. So all we actually have to do now to represent this on a number line is we stick our circle above that number, so above the 4 just here we'll stick a circle, and it's less than 4, so I'm just going to point it to the left, and it doesn't really matter how far I go, I'm just going to point an arrow saying it's got to be all these numbers here less than 4. Now obviously this circle here that I've drawn above the 4, let's do this in a different colour. This circle here can be open, and what I mean by open, just like I've drawn it there, it's empty in the middle, or it can be coloured in the middle. Now there's a little way of remembering whether it's coloured in or not. The other inequality symbol is we could have had this little equal to symbol on it as well. Now that little equal to symbol there has, and this is the way I like to remember it, it's got a little bit more ink on it in terms of when we draw it there's more ink. Now if there's more ink on the inequality symbol, there's more ink in the circle. So if it did have that little line underneath it, we would have a coloured in circle instead. There we go. But as this doesn't have the extra ink on the inequality, we're not going to put the extra ink there within the actual circle above the number. So we're going to leave it as an open circle, but I'm going to use that logic throughout these questions here. When we've got the extra ink on the inequality, we put the extra ink on the circle. That's just a nice little way of remembering it for you. It says solve the inequality and show it on the number line. So within this inequality here, look, we've got 2x plus 3. Now if I imagine that one of these sides wasn't there, let's just imagine this isn't here for the minute. If we just had that question, look, it's very similar to the one that we had in the first instance. Okay, we just subtract 3 and then divide by 2. Likewise, if we just imagine that the other side isn't there, I know it's written on the other side to what we had before, but again, we just subtract 3 and divide by 2 and we get our solution. Now we're not actually going to do anything different, but in this case, look, when we subtract this 3, to actually start isolating this x, all we're going to do is we're going to take away 3 from both sides. So I'm actually just going to take that away from both sides. I'm going to write minus 3 and minus 3. And when we do that, look, negative 5 take away 3 is negative 8. And that is the equal to symbol under that. Then we'd just be left with 2x in the middle. And 7 take away 3 there is 4. And there we go. Obviously I want to have x on its own. So now I want to divide by 2, just like we've done before. That'll give me the x in the middle. There we go. Keep all the symbols the same. Dividing them both by 2, 4 becomes 2, and negative 8 becomes negative 4. There we go, and now it's an inequality that we can draw on the number line. Now we've just got that x isolated in the middle. So it's a very similar process to what we did in those early questions. It's just that when we take away the 3 or potentially add the number if it was a negative in the middle there, we just do it to both sides. And then when we divide as well, just obviously dividing both sides. So very, very similar to what we were doing before. You just have to do it to the left and the right this time rather than just the one side. So again, putting the numbers on these. So negative 4 we've got a circle on, and positive 2 we've got a circle on. We're definitely going to join them together. I've just got to figure out if any of these are coloured in. So the one on the left there had the equal to symbol right next to that negative 4. So I'm going to colour that one in just to show that it can actually be equal to negative 4. Right, there we go. And that is our inequality there, drawn on the number line with a bit of solving in the middle. So I've got a couple of these for you to have a go at, both of them where you're solving in the middle. Again, you could always just think about the integer values that fall into this as well, just as an extra little step. So let's just write down the integer values. So we can have negative 4, it can be equal to that. We can have minus 3, minus 2, minus 1, 0, 1, and we can't have 2, so if you did write it, you'd have to cross that one out because we can't have the 2. There we go, so we can just get rid of that 2 at the end, and they are the integer values that fall between that inequality there, the whole number values. Obviously, we can have decimals in between 1 and 2, we could have 1.5, 1.7, you know, any old decimal that you can think of going in there, but we can't actually have 2 itself, so we won't include that in terms of an integer value. Okay, so the point 34 lies on the circumference of a circle, centre 0, 0. Work out the equation of the circle. That's quite a nice, actual, easy way of doing this, because if we know that this point is definitely on the circumference, then we can just use our equation of a circle. And there's 2 different ways I'm going to look at this, but I'm going to start off with this one, because this one's quite a nice one. Now we know the equation of the circle is x squared plus y squared equals the radius squared. So if we just plug these numbers in, 3 squared being the x coordinate, y being the 4, so 4 squared, and that's going to again equal the radius squared. So if we work this out, we get 9 plus 16, which equals 25. Again, that equals the radius squared. So if that equals 25, then we can write our equation there. So we have x squared plus y squared equals 25. There we go. And although it doesn't ask for it, again, we could think about what the radius is here. If we did the square root of 25, we would get 5 as our radius, okay? So obviously that's not part of the question here, it says work out the equation of the circle, but just thinking about that as well, you could actually get the radius there as 5. Now, if the centre wasn't at 0, it'd be a little bit trickier to do because we couldn't just sub it straight in. So we'll have a look at another way that you could look at this, because we're going to have a look at one where the equation of the circle, there we go, is not at centre 0, 0. But if we think about this as a little diagram, I'm going to do a little sketch of this. So if we had our circle, we've got centre 0, 0, 3, 4, let's just say it's up here. If we wanted to find the length of the radius, which obviously would help us to find the equation of the circle, we could actually draw this in. This is quite a good skill to be able to have here to be able to do this for the progression of this topic. But if we actually draw a line going from 0, 0 to 3, 4 and think about the kind of shape we could make here. So we could make a little right angled triangle. And thinking about what this little right angled triangle looks like, going from 0, 0 to 3, 4, well, if it goes from 0 to 3 on the x coordinate, that is a run here or a change in x of 3, and going from 0 to 4, that is a rise or a change in y of 4. So actually we could use Pythagoras to work out the length of the radius here. So I could just do a bit of Pythagoras, so square them both, add them together and square root them. So 3 squared plus 4 squared, and then square root our answer, which is the square root of 25, and the square root of 25 is 5. So there we go, that's another way of showing that the radius is 5. And then once you've got that, you can obviously put it into your circle equation. X squared plus y squared equals 5 squared, and again, squaring that 5 to get you 25 to get your equation of the circle there. Okay, so a slightly harder question here, and you'll see why when we work this one out. So we've got y equals mx plus c, and we're going to work out the equation of the line between these 2 points. So the change in y over the change in x, let's see what we get. So from 4 to 8 is positive 4, and from negative 3 to 5 is a movement of positive 8, so it's 4 over 8. Now I've got a fraction here, we can simplify that. So divide the top and bottom by 4, and we get 1/2, okay, or 0.5. Now it doesn't matter whether you use fractions or decimals here, it's completely up to you which one you prefer to use. I think I'm going to use it as a decimal, I'm going to keep it as 0.5, and let's put that into our line equation. So y equals 0.5 x plus c. Right, let's pick a coordinate. I'm going to go for this one here just because it's got 2 positive numbers in, but it's completely up to you, it doesn't actually matter which one you use. So let's sub that in. So we have 8 for y, so 8 equals, we've got 0.5, lots of the x coordinate there, which is 5, plus c. There we go. So 0.5 times 5, or half times 5. Let's have a look and see what that is. So we get 8 equals 0.5 times 5 is 2.5. Remember, if you times by a half, it just halves the number. So 2.5 plus c. And then we need to subtract 2.5 from both sides to figure out what c is there. I mean, you can just use logic. From 2.5 up to 3 is an extra half. And then it's an extra 5 to get to 8, so it's 5.5. But if we subtract 2.5 from 8, we get 5.5 equals c. And then we can plug that in place of c up in our line equation there. Okay, so let's write that out. We get y equals 0.5x plus this 5.5. There we go. And there is our line equation. So y equals 0.5x plus 5.5, which again you could write as a fraction if you want. So whatever value you get for the gradient, obviously just treat it as a fraction or a decimal, and just obviously careful on this step right here. Just when you multiply those to get this value of 2.5, whatever that decimal multiplication is, just be very careful with that. So a line passes through the points 1, 5 and 5, 7. Find the equation of a perpendicular line that passes through the point negative 1, 7. Now this doesn't give us a line equation, which means we don't have a gradient, which means we're going to have to work one out. So we have been given this information that a line passes through these 2 points. Obviously, if you remember from the last video, we can have a look at the change in y over the change in x to get the gradient. So we don't even need the line equation. Because we've got these 2 points, we can find it ourselves. So going from one point to the other, the change in y, which we're going to do over the change in x, but the change in y goes from 5 to 7, which is a change of positive 2. And the change in x goes from 1 to 5, which is positive 4 or 2 quarters. So if we simplify that down, we get a half. So our gradient at the moment is 1/2. So if I want the perpendicular gradient, which we do for this because we're looking for a perpendicular line, we'll do the negative reciprocal. So -2/1, which is -2. Right, there we go. And now we can put that into our line equation. So y equals -2x plus c. And then again, just like before, we can sub in our coordinate. So 7 is the y coordinate, which equals -2 times x, which is -1, plus c. -2 times -1 is +2. Those negatives cancel each other out. So 7 equals 2 plus c. Solving that, take away 2 from both sides to get c on its own. We get 5 equals c, or c equals 5, and we can put that back in place of c up here. So y equals -2x plus the 5 there. There we go, plus 5. And there's the equation of our line. Okay, so for this question, it's all the same process, but you're just going to have to find the gradient first. Okay, so find the equation of the tangent to the circle with equation x squared plus y squared equals 17 at the point 1p, where p is positive. Hence find the coordinates where the tangent intersects the x-axis. So there's 2 extra steps here. We've not got the coordinate where it intersects, and it's also asking us to find where it intersects the x-axis. So we're going to take this in steps, but let's have a think about what this would look like to start with. So we know it's a circle. We know its centre 0, so we can draw a little sketch, even if it's not very good. There we go. And we can think about where this coordinate is. So 1p, where p is positive, is going to be over here in the positive quadrant there. So let's have a look. Let's draw that in. Okay, let's just draw a little sketch of this. So that coordinate is 1p. I'm not going to write the p in for the moment because we're actually going to figure that out. And then we know it's centre 0, 0. Obviously, we're still going to be looking at finding out the gradient of the radius here. But we've got the tangent going down, it's intersecting the x-axis over here. So this here is where it intersects the x-axis. So this is what we're looking for here, this coordinate. And that's what we're going to find in a sec. So let's have a think about this. Now we can't find the gradient of the radius unless we know that coordinate there. So we can use this equation of the circle to find that coordinate. As we looked at with equations of circles, if this is definitely on the circumference of the circle, then it has to balance within that equation. So if we sub this coordinate into the equation, let's see what we get. 1 squared is 1 plus y squared, which we don't know. We could call it p squared if we want. And that equals 17. And if we solve that, so take away 1 from both sides, the 1 squared, we get y squared equals 16. And then the square root of that to get y. Y is going to equal either 4 or -4. Now it says that p is positive, so it's got to be the positive 4 there. Again, if it didn't tell us that p was positive, we'd have to have a diagram to know whether it was there, otherwise it could be either. But in this case, it does say p is positive, so p is 4. So there we go, we've got our coordinate for y there, 4. Now we've got that, now we can find the gradient of the radius. Okay, so we can draw in our little right angled triangle again, we can find the gradient and we can follow all those other steps. We will have a look at this last step though at the end, the coordinates where the tangent intersects the x-axis. That's going to be our final step, but first, if we find the equation of that tangent, we'll be able to use that to find that intersection point with the x-axis there. So following our normal steps, let's find the gradient. So the gradient is from 0, 0 to 1, 4, so that's going to be 4 as our change in y over 1, which is just 4, and our perpendicular gradient, negative reciprocal, minus 1/4. There we go, now we can plug that into our line equation. So y equals minus 1/4 x plus c. And let's sub in this coordinate. So we've got 1, 4 to sub in. So 4 equals minus 1/4 times 1 is minus 1/4. So that's quite a nice one, minus 1/4 plus c. And then adding 1/4 to both sides, we get 4 equals, sorry, I've not actually added the quarter over. Add the quarter over, we get 4 1/4 equals c. And then from there we can write our line equation, plugging that value into c up there. So we get our line equation as y equals minus 1/4 x plus 4 1/4. There we go. And obviously up until this extra step, that's what we've been doing on the previous questions there, with the extra step of actually finding the coordinate. Well, that wasn't too tricky in this step here, just to get y equals 4. So now it says, Find the coordinates where the tangent intersects the x-axis. Now this is something that always tends to throw people, but right here, this coordinate, we actually already know one of the coordinates there. We don't know the x-coordinate, obviously, but we do know the y-coordinate, okay? The y-coordinate has to be 0, okay? Because it's on the x-axis. You think about the y-axis over here, this is 0, we already know 0, 0 there is on the x-axis, so the y-coordinate has to be 0. And because we know that we can sub 0 in place of y here in our equation. And if we do that, so we know y is 0, we can have 0 equals minus a quarter x plus 4 1/4. There we go. And that we can only do that because we know the y-coordinate at that point. Now we just have the one unknown in our equation, we just have this value of x, so we can try and solve this for x. So if we subtract for this 4 1/4 from both sides, we get minus 4 1/4 equals minus a quarter x. And then we can divide both sides by negative a quarter. So we've got 4 1/4 divided by negative a quarter. They're both negative, so our answer is going to become positive, which we know it's going to have to be positive as it's over in the positive quadrant there. And if we divide by negative a quarter, well, a quarter fits into 1 4 times, so it must fit into 4 16 times, plus the extra quarter there gives us 17. So if we solve that, we get x equals 17. Okay, that's just me doing negative 4 1/4 divided by negative a quarter. Again, if you've got a calculator, that's nice and easy, but just remember a quarter fits into 1 4 times, so it has to fit into 4 16 times plus the extra 1 there, which is 17. So the coordinate there is 17 0, and that'd be our final answer there, 17 0. There we go. Lots going on that question there. And again, don't forget, you could always use your fraction rules. If you didn't have a calculator, it wasn't a nice easy one, you could do, let's have a think how we would write that. The negative 4 1/4, we could make that top heavy. So 4 times 4, 4 big times the bottom is 16, plus the 1 is 17, so it's negative 17 over 4 divided by negative a quarter. And you could just apply normal fraction rules to that, so keep the first one, flip the second one over, and then simplify it. So you do 17 over 4 multiplied by 4 over 1, and then obviously just simplify it from there. So there are other steps you could take if it was particularly nasty. Okay, so this one here, we've got it a little bit jumbled up, it's a little bit different to the last few, but let's just follow the exact same process and see what we get. So first bracket, 4 times the x gives us 4x, and 4 times the negative 3 gives us negative 12. Now moving on to the next bracket, but again, just being careful because we've got a negative 2 at the start. So this time it's negative 2 times the number first this time. So negative 2 times 1 is totally negative 2, so take away 2. And then we've got negative 2 multiplied by negative x. So the negatives are going to become positives because we've got a negative multiplied by another negative. So we've definitely got positive. And that's 2 times the x, so plus 2x. Negative 2 times negative x is positive 2x. And again, just tidying this up just like before, so 4x and the other x is at the end this time, so 4x plus 2x is 6x, and negative 12, take away 2, is negative 14, so 6x minus 14. Again, just be very, very careful with whether the number is negative or not. Obviously this was a negative 2, particularly careful when you times it by this negative x there to make sure you get your symbols right. Here we go, so expand and simplify this one, so we have 2x minus 1 and 2x minus 5. So let's see what we get here. So 2x times 2x is 4x squared, and 2x times negative 5 is negative 10x. On to the underneath, negative 1 times 2x is negative 2x, and negative 1 times negative 5 gives us positive 5, 1 times 5. And then again, just finishing it up, tidying up what's in the middle here. Both are negative, so just be careful. We've got 4x squared, negative 10 take away 2 is negative 12. So negative 12x, and then plus 5 at the end. And that's how you expand them when we've got coefficients greater than 1 in the bracket. We've got negative 2x in the middle and negative 15 at the end. So let's draw our brackets and think about what numbers times to make 15. So we've got 1 and 15, or 3 and 5. Now we've got negative in both of these, so the only options I can have to get a negative 15 at the end, I've got to have one that's positive and one that's negative. Okay, otherwise we're not going to get a negative answer at the end. So let's have a think about that while we're doing it. So 1 and 15, there's no way I'm going to make negative 2 out of those two numbers. 15's too large, pairing it with the 1 there, so it's not 1 and 15. but I can make -2 out of 3 and 5. Just got to be very, very careful here the way that I get it round, because I can either have -3 and +5, or I can have +3 and -5. So I just got to think, in order to get -2, the pairing that I want to do is I want to have 3 take away 5. So I want to have +3 take away 5, and that would allow me to get -2. So I just need to stick those numbers in, +3 -5. And when you've got this option with the positive and the negative, do make sure that you double check, just thinking to yourself in your head, +3 take away 5, does that definitely make -2? Yes, it does. So we're happy with that one. We've got a 2x squared. So again, I'll link in the description the video for obviously factorising harder quadratics. I will explain them a little bit, but I won't go into as much depth as I did in that video. So do check that one out if you're not sure on how to factorise these. Now in terms of a 2x squared, that means in one of our brackets here, we're going to have a 2x when we're factorising it. So if I set the brackets up, we've got a 2x and an x, it's all equal to 0, and we just need to figure out where the numbers go. Now if we've got a 1 at the end, our only factors can be 1 and 1, but one of them is going to be doubled. Okay, obviously when we expand our double bracket here, we've got a 2x and it's going to double that 1 in the other bracket. So as they're both 1s, we know they're both going to be 1s here. We just need to figure out the symbols. Now we want -1x or -1 in the middle. So in order to make -1, we're going to want +1 take away 2. So as this one over here is going to be doubled, we'll make that one become our -2, and this will be our +1 here. And obviously you can go about expanding that just to check that it matches, but there we go, that is going to match. We're going to get +1 on this expansion here, +1x, and we're going to get -2x when we expand that one there, and that'll give us -1 in total. So in terms of obviously getting our solutions here, it's very similar to what we just looked at. If we just set them both equal to 0, this one here is just going to become x equals 1. Obviously we haven't got a coefficient there, and this one here, we're going to flip the sign, so x is going to equal -1, but then we're going to divide it by the 2. So -1 over 2, or -1/2. And there's our two solutions, x is -1/2 and x equals 1. And again, you could obviously draw your sketch for your quadratic there. Just thinking about what it looks like, it's going to go through 1 and -1/2. And you could draw that in, there we go, 1 and -1/2. And that's where our two solutions are. So let's have a look and let's just write down the values of a, b and c. I always write these down. So a equals 3, b equals 2, and c equals -13. So sticking it all in the formula, we've got -b at the start, so -2, plus and minus the square root of b squared, so 2 squared, minus 4 times 3 times -13. And that's all over 2a, which is 2 lots of 3. I'm going to type in 2 times 3. There we go. Right, so got to be very careful here because there's a -c value. What's going to happen is that number, that 4ac part, is going to be negative, but because we're taking it away, it's going to turn that into a plus. Now you've got to be careful. If you type this in wrong and you do forget to put the negative in or something like that, you're going to get an error on your calculator screen. It's normally a syntax error or error. Again, that will be because you have got a negative number underneath the square root there. Now this can happen if there's no solutions, but obviously if we are looking to get a solution here in this type of question, we shouldn't be getting an error, and you can't square root a negative number. So just be very, very careful if that does come up. It just means you've probably ended up with a negative under there, which is unlikely to happen on a question like this. So right, I'm going to type this in. What I'm going to do is I'm going to do the plus version, and then I'm going to do the negative version. We'll have a look at them both separately. So on my calculator screen, I've got -2 plus the square root of, I'm just going to type it in as I see it, 2 squared minus 4 times 3 times -13, all over 6. And again, let's type that in, fraction button, -2 plus the square root of 2 squared minus 4 times 3 times -13 onto the bottom of your fraction, 6 equals, and turn it into a decimal. So we've got 1.774851773, and let's round that straight away. We get 1.77 as our first solution there. So there we go. There's our first solution. And then having a look at our second one. Let's see what we get for this. So we've got the same equation up there, but with the plus. So with the plus, but with a takeaway. So take away 2 squared minus 4 times 3. Oh, that's a weird 3 times -13, and that's all again over 6. And let's see what we get for this one. So back into your calculator. Don't delete anything. Just delete that plus swap it for a minus, and again turn it back into a decimal. So you get minus 2.44151844. Just make sure you do always write down all the decimals before you round it here. But rounding this to 3 significant figures, we get minus 2.44. There we go. So obviously, hopefully you followed along with me there. Do check that you're getting the same answer as me on your calculator. Just lets you know that you are typing it in right, and obviously you can have a look and amend it if it's not coming up with the same answers there. Okay, so it says write this x squared minus 8x minus 4 in the form x minus a squared minus b, where a and b are integers. So it doesn't say complete the square, but that there is completed square form. Okay, so that's what we're going to do. We're going to complete the square, and then it says hence find the coordinates of the turning point for the graph with equation x squared minus 8x minus 4, the same one that's up there. So what we're going to do is do exactly the same thing, completing the square, and then find the turning point. So I'm going to do it from this one below, but this time it's a minus 8 there. So when I halve that, it'll just be minus 4 in the bracket. There we go, squared. Always in that form, so we've already got a there. A is going to be 4. Now, just thinking about obviously expanding this, the final multiplication we do in a double bracket will be negative 4 times negative 4. That would give us 16. And we don't want the 16, we want that negative 4 there. So in order to get to negative 4, we would have to subtract 20 to get to negative 4. So it's minus 20 at the end there. So there we go, A is 4 and B is 20. Now, in order to write the turning point, we're going to take exactly the same approach. Look, we flip the sign for the minus 4, so our x-coordinate is positive 4, and our y-coordinate is just this number at the end, minus 20. There we go. So the inverse function of x just means essentially what is the opposite or the reverse of this function. Now, the function at the moment, 3x plus 4, just means that whatever number you put in, it gets multiplied by 3 and then you add 4. And if we think logically, the reverse of that would be taking away 4 and dividing by 3. But we're just going to have a look at a process for actually working out a method for how we could actually go about writing this expression out for this inverse function. Now, it's just personal preference. There are lots of ways of doing this. This is just the way that I like to do it. Now, instead of writing the function of x equals 3x plus 4, I like to just write y equals 3x plus 4. So I write y equals 3x plus 4, and now what I do is I rearrange it to make x the subject. So if I want to make x the subject, first thing that I do is I'm going to have to take away 4 here. Obviously it's just rearranging equations, so you can always have a look at my video on rearranging equations. But minus 4 from both sides would leave you y minus 4 equals 3x. And then to get x as the subject, we would divide by 3, and we'd get y minus 4 all over 3 equals x. Now obviously the y I only put in place there just to help me rearrange it. Obviously this isn't a very nice piece to rearrange, f of x, okay, so it's just easier just to replace it with a letter. And what we're going to do here now is just swap the x and y over to put the x back in, and that would leave us with x minus 4 over 3 rather than y minus 4 over 3, and that equals the inverse function of x. Okay, and think back to the logical idea there. We said x would help you to reverse timesing by 3 and adding 4. You would take away 4 and divide by 3, and that's what's shown there in the inverse function, x take away 4 and then divide by 3, and that is our inverse function. Okay, so all we're going to do is write y equals instead of f of x, make x the subject, and then swap x and y. So 3 little steps there with some rearranging. Let's have a look at another one. Okay, so this question says, given that f of x equals 2 brackets x plus 2, work out the value of f minus 1 with a 10 in there. So that f minus 1 still means the inverse function, but with a 10 in there means it's going to want us to do something with that in a second. We'll talk about that once we get the inverse function. But first things first, we can see this inverse f, so let's find an expression for the inverse of f. Now straight away we've got some brackets there, so we need to expand these brackets. So let's expand that straight away when we write y equals. So y equals 2 times x, which is 2x, and 2 times 2, which is 4, so plus 4. And let's find the inverse function. So subtract 4 from both sides, y minus 4 equals 2x. Divide by 2, we get y minus 4 over 2 equals x. And let's write our inverse function. So f minus 1 of x equals x minus 4 rather than y minus 4 over 2. Now whenever you're given a number in the brackets here, it just means it wants you to replace x with the number. That's why it says work out the value. So all I'm going to do is I'm going to sub in x equals 10 into my little expression here. So I've got x minus 4 over 2, and that's going to become 10 minus 4 over 2. 10 minus 4 equals 6, so it's 6 over 2, which gives me a value of 3. Okay, so find the inverse function and then sub that number in. There is another process to actually go about solving this, but I think it's a good process just to write out the inverse function and then sub it in, because there's two elements of the maths going on there rather than applying a little trick here.
Okay, so here we're looking at the triangular numbers. Now it says here the triangular numbers are 1, 3, 6, 10, and then the sequence continues. It says the nth term of this sequence is a half n brackets n plus 1, where n is the position within the sequence. So it says find the 200th triangular number. So to find the 200th triangular number, we just substitute it into our nth term, which we've got just here. So we would do a half multiplied by 200 to start with, and then that is going to be outside the bracket where we have 200 plus 1, and ultimately we're just going to multiply those as well. So a half times 200 would give us 100, and then inside the bracket we've got 201. So all we actually have to work out here is 100 multiplied by 201, which is going to be 201, and an extra 2 zeros there, which is 20,100. And there we go, that would be our final answer.
Okay, so this one's slightly more complicated because as you can see at the top, look, we've got £360 shared between Abby, Ben, Chloe and Dinesh. So there's 4 people in this one. So let's have a look. It says the ratio that Abby gets to the amount Ben gets is 2 to 7. So we've got Abby, we've got Ben, we've got Chloe and Dinesh. And it says Abby to Ben is in the ratio 2 to 7. And it says Chloe and Dinesh each get 1.5 times the amount that Abby gets. So both of these people here are both getting the same amount. They're both getting times 1.5 the amount that Abby gets. And 2 times 1.5 is nice and easy for us to work out. Half of 2 is 1, added on gives us 3 for both of them. And there we go. And then all we've got to do is split it in a ratio just in the same way that we have done before. The total of all those parts, if I do this below, if we add them all together, we get 15. So we've got 15 parts equaling £360. And then again, we can divide that by 15, and 360 divided by 15 gives us £24. So we've got that 1 part equals £24. There we go. And it says work out the amount of money that Ben gets. Well, Ben gets 7 of the parts. So if Ben's going to get 7 of them, Ben gets 7 lots of the 24 quid, which is going to be in each pile. So 7 times 24 gives us a final answer of £168. And there we go. And there's our final answer there. And again, we could work out how much they all get. Abby gets 2 of them. So 2 lots of 24 is 48. And then Chloe and Dinesh both get 3 parts, and 3 times 24 is 72. So we could do that. And then again, you could add them all up and check that they equal 360. But again, we're going to try and minimise the amount of working out we do here. So just straight away getting the amount that Ben gets. Okay, so this question here looks like a 3-part ratio. We've got the points A, B, C and D line order on a straight line. We've got A to B, B to D is 2 to 5, A, C, C, D is 4 to 7. And we want to find the ratio A to B, B to C, C to D. So it looks like, and it is going to be a 3-part ratio the way we look at it, but it looks like we're going to have to try and find some sort of crossover. Now, if you have a look, A to B is not in either of the other ratio. B to D is also not in either of the other ratios, so we've not got a crossover. So we're going to have to think about this slightly differently. Now it does say that they lie on a straight line, so if we just imagine this line, let's just imagine, here it is, here's a line, we've got A, B, C, D, and let's just label this up. So we've got A, B, C and D. Now it says the ratio A to B, B to D is 2 to 5. So that's this bit here, and I'm going to do this in a different colour. We've got A to B there, and that's 2, and then B to D to the end, 5. Then we've got the other ratio that's given to us. We've got A to C, which is 4, and we've got C to D, which is 7. Right, so we haven't got a crossover, but we have got totals. And what we're going to have a look at is if we have something like this sort of scenario where we can draw a little picture, we can actually just combine both these ratios together by looking at them if the totals add up to the same. What I mean by that, look, is 2 and 5 gives us a total over here of 7. The other one, 4 and 7 over here, gives us a total of 11. Now, if they both had the same total, this would make this problem a lot easier. So let's think, what's the lowest common multiple of 7 and 11? Well, that is 77. So to make these numbers out of 77, I would have to times the top one by 11 and the bottom one by 7. And that would give me new numbers here on my number line. So if we change this, look, we've got 22, and we times that by 11. And here we've got 55. And on the bottom there, 4 times 7 is 28, and 7 times 7 is 49. Now that they have the same totals, we can pretty much just get the readings from our picture. So A to B, we've got up here 22, and that's the first part in our 3-part ratio there. So let's have a look. We've got A to B, which is 22. Now we're looking at B to C. B to C we can't find because it's crossed over on the other two, so there's no way we can get that at the moment. But then C to D, we've got that, that's given to us down here. C to D is that 49. So we've got 49 at the end there, we're just missing the one in the middle. And here's a bit of an idea of how do we actually find that number in the middle. Now we know that the total over here had to add up to 77, that's what we did, we made these both add up to 77. So this total that we're looking at has to add up to 77, okay, just like those other two. These have to add up to 77. So what have we got at the moment? We've got 22 and 49. Let's add those together, see what we've got so far. 49 and 22 make 71. So to get from 71 to 77, we would have to add in an extra 6. And there we go. And there's our 3-part ratio here from a diagram. So something a little bit different, okay, you do have to draw a little picture for this. I think it's probably quite difficult unless you draw a picture, but there's just something a little different just to finish this off when we're looking at this combining ratios, and rather than looking at a crossover, we're looking at the total between them so that we're able to combine them together and have a look at these sorts of missing distances in the middle. Okay, so in this question we're going to have a look at some percentage increases and decreases. So it says here at the end of 2015 the value of Alice's house was £240,000 and the value of Carl's house was £170,000. At the end of 2018, the value of Alice's house decreased by 20% and the value of Carl's house increased by 30%. Who's had the greater value at the end of 2018? And again, you must show how you get your answer. So again, we're going to use a calculator method here, and we'll start with Alice. So if her house has decreased by 20%, again we could use a multiplier of 80% because it's gone down by 20. So if we multiply by 0.8, that's going to straight away give us the value of the house. It's going to decrease it by 20% for us. Now if we do that, that comes out as 192,000. So Alice's house has gone to £192,000. Now when it comes to Carl's house has actually gone up in value. So we wouldn't multiply that by a 0 point number, but instead we would multiply it by 1 point, and for this it's 30, so 1.3. That's going to increase it by 30% for us. So if we again just type that in on the calculator, that comes out as 221,000. So straight away we can see by our working out there that Carl's house has the greater value at the end of 2018. So as it says here, whose house has the greater value, we would just make the statement like before, Carl's house has the greater value. There we go, and again that is backed up by our figures, so we don't need to put exactly how much more or less Alice's is worth. We can just say that Carl's house has the greater value, and that is backed up by our working out as shown above. Okay, so this question here, it says Tame Valley is a company that makes yogurt. A machine fills 20 pots with yogurt, and in 1 hour it fills a total of 15,000 pots. How many seconds, or work out how many seconds the machine takes to fill a tray of 20 pots. So in this question here, we've got one piece of information that is mentioning hours and one that's mentioning seconds. We've got in 1 hour it fills 15,000, but it wants us to work out how many seconds it takes to fill one of these trays. So we've got a little bit of time conversions going on. So to start with, what we could work out here is actually how many times it's going to have to fill up this lot of 20 pots. So in the hour it's going to fill up 15,000, and each time it's filling up 20. So if we do 15,000 and we divide that by 20, it's going to tell us how many times it actually has to fill up this these 20 pots. So 15,000 divided by 20 comes out as 750. So essentially it has to do this 750 times, and each one of those 750 times it's filling up 20 pots. So that is going to take 1 hour, but we obviously want it in seconds. So if let's turn the amount of, let's turn the 1 hour, I was going to say the amount of hours, but we've only got one. So let's turn the 1 hour into seconds. Now in 1 hour, there are 60 minutes. And in each one of those minutes, there are 60 seconds.
So if we do 60 times 60, that tells us how many seconds are in 1 hour. And that's nice and easy for us to work out. 6 times 6 is 36, and add 2 zeros. So in total, to fill up these 750 times, it's going to take 3,600 seconds. So to work out how long it's going to take to fill up one of those, we'll do 3,600, the total amount of seconds, and we'll divide that by the 750 times, and it's going to tell us, and it gives us here 4.8 seconds. And that's how long it's going to take to fill up each tray of 20. And that'll be our final answer there, and that is just being very careful with your time conversions and getting that 1 hour written in seconds.
There's a lot more words in this question. It says it takes 8 machines 9 days to complete a job. On the first day 3 machines are used, on the second day 6 machines are used, and for the remaining days 7 machines are used. I just realised that says are's used. There we go, let's get rid of that. It should just say are used. How many days does it take to complete the job? So first things first, we've got this first bit of information here, 8 machines and 9 days. So we can work out one machine, so 8 times 9 gives us 72 days in total for this job to be completed by one machine. Now it says on the first day 3 machines are used, so that's 3 days worth of work there. That's only on one day, okay, but on that first day, let's just label this on the first day, there's going to be 3 days of work done there, okay, so 3 days. There we go. So that's one day, but 3 machines. So in total, that's 3 of those 72 days that were going to be done there if it was one machine. It says on the second day, 6 machines are used. So on the second day, we've got 6 machines. That's only for one day again. So it's just going to be 6 days of work. Again, it could say for 2 days there. That'd be 12 days, but it's only one day. So 6 machines, 6 days of work there. And for the remaining days, 7 machines are used. So in total, we've done 9 days worth of work there. Okay, the 3 and the 6, 9 days of those 72 have been done. So if we take away those 9 days, how many actual days do we have left there? And 72 take away 9 leaves us with 63 days of work that needs to be done. Okay, so we have 63 days that need to be done. Right, so it says for the remaining days, 7 machines are used, and we've still got 63 days of work to be done. Technically 63 days, but we are going to be using 7 machines, so it's going to be 7 times faster than if it was just one machine. So let's divide that by 7, and 63 divided by 7 leaves us with a remaining amount of days there of 9. So there are going to be 9 days done in those remaining days where we have 7 machines. Now we've not quite finished the question here, because not forgetting we did have the first day where we used 3 machines, the second day where we used 6 machines, so 9, add those additional 2. So add the extra 2 there from above, would give us in total 11 days that it's going to take to do this job. Okay, 2 days where we've got the 3 and 6, and then 9 additional days where we are using 7.
Okay, so looking at some pressure, force and area. It says here a force of 70 newtons acts on an area of 20 centimetres squared. It says the force is increased by 10 newtons and the area is increased by 10 centimetres squared. Does the pressure decrease by less than 20%? And you must show how you get your answer. So if we work out the pressure to start with our original numbers, we have 70 newtons, which is our force, on an area of 20 centimetres squared. So if we put that into our formula, we've got 70 divided by 20, and that gives us an answer of 3.5 as our pressure. Now, if we look at increasing the newtons and increasing the area, instead of having a force of 70, we'd have a force of 80. And instead of having an area of 20, we're going to have an area of 30. So if we work out 80 divided by 30, we get an answer which comes out as 2.6 recurring. So it has gone down, so we can see it has decreased. But the original pressure there was 3.5. So does it decrease by less than 20%? Well, if we look at that actual pressure there of 3.5, we work out 20% of that, and we can do that by just multiplying it by 0.2, or we could use a percentage multiplier, or a sort of decrease multiplier, of multiplying to reduce by 20%. That multiplier that we can use if we take away 20% from 100% is multiplying by 0.8. So if I multiply by 0.8, and again you don't have to use a multiplier, you could just work out 20% and take it off, but this is a nice quick way of working it out. You get the answer 2.8. So if we were to have decreased it by 20%, it would have gone down to 2.8. And as we can see, it has actually gone down to 2.6 recurring. So it's gone down by more than 20%. So this question says, does the pressure decrease by less than 20%? Well, no, the answer is it would decrease by more than 20%. So we would have our working out there, but we would say no, it decreases by more than 20%. And that would be our final answer. So when you've got something like this, we do not have to say exact figures here, but it's fine for us to say it decreases by more than 20% as we have the correct working already shown next to the question backing up that statement.
It says here the diagram shows the plan, front elevation and side elevation of a solid prism drawn on a centimetre grid. Draw a sketch of the solid prism, give the dimensions of your prism on on your sketch. Now this isn't the nicest of ones to draw, it's actually quite similar to one that I drew earlier. Now you can see from the front, okay, which you can also sometimes imagine as the side, it sort of has this like look as if it's almost like a little step, okay, obviously not a full set of stairs but like a little step. So from the front there we could sort of draw this in. There we go, obviously it does require you being able to draw for this, which is, there we go, not the easiest, but there we go. That from the front we've got this sort of shape going along like this, there we are. Let's have a go. I'm trying to draw this as best as I can. There we go. There we are. We've got this sort of shape going on, okay, sort of like a little step. Now obviously that matches on the plan as well, okay, just check this out. You've got the face there and the face here, and on the left there you've got the green face, that's 3 along there, and the green face here. There we are, so we can see those. Hopefully obviously you can already see obviously this face here is matching this one here, and then you've also got the side, and I'll try and draw this in. You've got this one down here from the side which matches this face here, and we've got one more. I'm going to run out of colours though. What have we got? Not very nice colours there, let's go with blue. Right, okay, so you got this one here that matches that one there. There we go. And that is how we're going to draw this little sketch of this prism. Okay, obviously it does say we need to add the dimensions on as well, so we just want to have a little look. So along the front here, that goes along 5. So I want to put 5 centimetres along here. And it goes up by 4. There we go, so we'll put that on the side there as well, 4 centimetres. Along the pink face there, we've got 3 along, so that's going to be 3 centimetres. We've got a few other dimensions that we could add on as here. We've got this one here, which is 2 going up, and this one here, which is also 2. So we'll put that on as well, so 2 centimetres there. Just get rid of that bit if I can. There we go, 2 centimetres there, and also we have 2 centimetres up there. Is there any more that we wanted to? We could add on. We could probably add on these ones as well. We've got 3 there, which is up here, 3 centimetres, and we've also got, it's hard to draw in now, but that one there, which is 2 centimetres, so that's 2 centimetres there as well. There we are. That is literally every single dimension we could put on there, onto that particular prism. So just sort of filling it with all of the different dimensions that we could possibly put on that diagram. But there we go. That is how we go about drawing that one. Hopefully that helped a little bit with the colours being added on. Obviously it does require you just to be able to think about these shapes and being able to draw a little 3D sketch. So some of them are quite nasty. This one in particular is not the nicest to actually be drawing, but obviously you just got to try and draw it as best as you can. That's why it does say in the question, draw a sketch. Okay, so obviously using a pencil and a ruler if possible, but just trying to draw it as best as you can. Okay, and not stressing too much if your diagram doesn't look absolutely perfect. Okay, so just as best as you can. That's what a sketch is.
Now this one here is asking us to work out the volume, and you can notice that we've not been given the height. But you might also notice that inside the cone there, you can see that there is a right-angled triangle. Now, if we can make a right-angled triangle, which we can inside a cone, then we can perhaps use a different element of maths. And you should know that when we are using right-angled triangles, perhaps we might use Pythagoras and perhaps we might be using some trigonometry. Now, just for this one, we're not using any angles, we are just looking at a length, so we can actually use Pythagoras to work this out. And if I was to draw this triangle to the side, you can see that we have the hypotenuse, which is 12.6, and we have one of the shorter lengths, which is 5.7, and we want to work out this length here. So when we are using Pythagoras, we are going to do both the numbers squared. We're either going to add them or take them away from each other. In this case, we'll do a takeaway because we're looking for a shorter side, and then we'll square root our answer. So to get the height, we are going to do 12.6 squared take away 5.7 squared, and then square root the answer. And if you're not sure on Pythagoras, again, I'm going to link that for you so that you can have a look at some Pythagoras if you need to. So if we type that into our calculator, and you can type it in one go, so 12.6 squared, take away 5.7 squared, we get an answer, and it comes out as 11.236,99248. Now that is now our height, so we can actually go about working out the actual volume of this cone now. But you've got to be careful because obviously that height there is quite a long decimal and we don't want to round it until the very end, so I'm going to leave that on my calculator. Now we can actually go about working out the volume, so I would do 1/3 multiplied by pi multiplied by the radius squared, which is 5.7, so times 5.7 squared, multiplied by this long decimal, so 11.23699,248. There we go. I'm going to leave that number on my calculator so I don't have to type it back in. So I've got 1/3 multiplied by pi multiplied by 5.7 squared, and then I'm just going to press times the answer, and that will put that previous answer in, and I will get a final answer here of 382.3212,343. And again, finishing this question off, we just need to round it to 2 decimal places, so after the 2, and that is going to give us a final answer here of 382.32 volume again, so centimetres cubed. And there we go, there's our final answer. So as you can see, even if we don't have the height, we can use other elements of maths. In this case, we were using Pythagoras to work out that height and therefore work out the volume. Okay, so this says work out the surface area of the hemisphere and give your answer to 2 decimal places. Now, if we're going to work out the surface area of the hemisphere, bearing in mind if this was volume of a hemisphere, it would be nice and simple. You would just work out the volume and then you would just divide your answer by 2. But when you're working out the surface area, it's a little bit more complex because we're not just looking at half of the surface area of the full sphere, if it was a full sphere, but we are also having to include the surface just here, which is a circle. And the area of a circle, let's not forget, is pi r squared. So we've got another formula we're going to need if we are looking at the surface area of a hemisphere. So we can work out both these pieces, but we can start by looking at the circle. So to work out the circle, and if we just label this as the circle, we're going to do pi r squared, which is pi times 8 squared. So pi times 8 squared, you can work that out on the calculator, and that comes out as 201.0619298. I'm going to leave that full answer there as well, because when we add that to the remaining surface area around the outside, we don't want to get any rounding errors before our final answer. So now on to the curved surface area, okay, the curved part around the outside, so I'll label this as the curved. Now there are 2 ways that you could do this. Either you take the original formula, which we know is 4 pi r squared, and you work that out and divide it by 2. Or you can actually just divide the formula by 2. So what I could actually do is just take 4 pi r squared, divide that by 2, and instead we get the formula 2 pi r squared. And that is absolutely fine for you to use as well. Okay, so that might just save you a little bit of time in terms of the process, because instead of using the formula and then halving your answer, you're just going to straight away get half of that answer. So if we use that formula instead, as it is half of a sphere, then we, instead of doing 4 pi r squared, we're going to do 2 times pi times 8 squared. And if we type that in, let's see what we get. 2 times pi times 8 squared, and we get the answer 402.1238597. And there we go. And that is the curved part of the hemisphere. Now obviously we are looking at the overall surface area. So we want to take both of those pieces there, the 201 and the 402, and add them both together. And if we add them both together, we're going to get to a final answer. So if we write that working out down, we've got, and let's just write this down just below, we've got the 201.06 with a few more decimals, and we're going to add that onto the 402 number, which is 0.12 with a few more decimals, and let's see what we get when we add them together. So I've got the 402 already on my calculator, so I'm just going to add the 201.06 0.0619298, and I get a final answer there of 603.1857895. There we go, and that is my final answer. Again, just looking at the question, because it says round it to 2 decimal places, so I just want to chop that after the second decimal, which is after the 8, so 5 afterwards, so it is going to round up. So my final answer, and I'm going to have to write this at the top, is going to be 603.19. Now we're looking at surface area, it's in centimetres, so we would say centimetres squared. And there we go, there is our final answer for the surface area of a hemisphere. Okay, so moving on to a slightly different question. Now, as with all of these questions, even though this isn't a particular practice question for you to have a go at, I would encourage you to just pause the video and have a go and think about why you would struggle to work this out, if you would struggle with it at all. And this particular question is actually quite a tricky one. It says that ABCDE is a pentagon. Work out the area of ABCDE. Again, those letters ABCDE just refer to moving around the shape ABCDE, finishing the connection, and it forms the pentagon. So in order to work out the area of this, we need to split it into different shapes. Now there are a couple of different ways that I can think of as to how you could split this. You could split it down the middle potentially, and that would make 2 trapeziums either side. Or potentially you could split it across the top, and that would make a rectangle and a triangle. Now I would assume that the rectangle and the triangle would be easier than splitting it into 2 trapeziums, but let's just have a go and see what happens. So for this one here, the easy area to work out is obviously the area of the rectangle on the bottom, and that is just going to be doing 4 times 8. So 4 times 8 is 32, and that gives us an area of 32 centimetres squared. Now we have to think about the area of the triangle. We know for the area of a triangle, you need to do base times height, and we know that the base of the triangle is 8 as it matches the base of the rectangle down on the bottom here. But we also need the height of the triangle, and unfortunately we don't have that height. So we're going to have to think about how we're going to get the height. So let's move this 8 to the side, and let's just think about that length there, which is the height. So how would we go about getting that? Now looking at what we have there, we've now split it up into 2 right-angled triangles. If I could draw this right angle in here as we are looking at the perpendicular height. And down here, if we split up that 8, which might just help us here, we would have each triangle on the left and the right having a base of 4. Now does that help us to work out the height? And hopefully you've spotted that in order to work out a missing length in a right angled triangle, you would have to use Pythagoras' theorem. So to use Pythagoras for this, that is obviously involving a whole new topic now. And again, I will link Pythagoras' theorem for you if you're unsure on how to go about using Pythagoras. But to use Pythagoras' theorem, we square the side lengths that we have on the 2 other parts of the right angled triangle, and then we're going to add or subtract depending on whether we are looking for the hypotenuse or not. In this question, we're not looking for the hypotenuse, we're looking for a shorter side, so we would do the square root of, and again I'm doing this in one step, but 5 squared take away 4 squared. Again, you can do 5 squared take away 4 squared and then square root it, but if we just do that in one step, we've got the square root of 25 take away 16, which is the square root of 9, which comes out as a length of 3. So the height of the triangle has a length of 3. That is now going to allow us to work out the area of that triangle because we have the height. So it's up to you. You could work out the area of one of those triangles and then double it, or we could just go back to working out the area of the full triangle here, which is going to be the base times height divided by 2. Now the base of the whole triangle was 8, so we have 8 multiplied by the height, which is 3, and then we're going to divide that by 2. And that comes out as an area of 12. Again, it's in centimetres, so centimetres squared. So we've got the area of the rectangle, which is 32, and we have the area of the triangle, which is 12 centimetres squared. So to finish this question off, we would add them both together, and that is 32 plus 12, which comes out as an overall area of 44 centimetres squared. And there we go, that is our final answer for working out this area. So as you can see with this question, I've already introduced where we may have to work out the area of a compound shape, and it may actually involve us to use something like Pythagoras. So there's another example of a compound area question where we have a different topic being involved, which is the very nature of these problem-solving type questions.
Okay, so in this question it says two cylinders are mathematically similar. The height of cylinder A is 3 and the height of cylinder B is 9. The volume of cylinder B is 540 centimetre cubed. Work out the volume of cylinder A. So again, there's no pictures, again, which it may or may not give to you, but I can easily draw one and it doesn't have to be perfect. So let's call this cylinder A, and let's call this one cylinder B, which I'm going to draw just a little bit bigger there. Because I can see that the height of that is 9 rather than 3. Again, this isn't to scale, it's just to give you a little visual idea. So this is 3 centimetres as the height of A, and this is 9 centimetres for the height of B. Now it does also give us another piece of information, so let's write that on. It says 540 centimetre cubed for the volume of B there. Okay, just making sure you label that appropriately. Okay, it's always a good idea to highlight some of the information. Height of A is 3, height of B is 9, and then the volume of B is 540. And we're going to work out the volume of A. So again, we just need to work out what our scale factor is. Now again, we've got 3 and 9 there being the heights, so I can work out my length scale factor by doing 9 divided by 3. Again, the bigger one divided by the smaller one, and 9 divided by 3 is 3. Now again, on this case, I'm going to be thinking about, do I want my area scale factor or do I want my volume scale factor? Now the question here is asking us to work out a volume, so I can ignore area, and to get from length to volume, in this case here, we would cube it. Again, just thinking about the units within that, it's centimetre cubed. So to get from length to volume, you would cube it. So our volume scale factor is going to be 3 cubed. And 3 cubed, we can actually work that out. 3 cubed, 3 times 3 times 3 is 27. So that's the scale factor we're going to use here when we're looking at volume. Right, so we are working out the volume of A. So I'm going from the big one down to the little one. So I'm not going to multiply this time because the volume is definitely getting smaller. And all I have to do differently here is I just divide by the scale factor. So I divide by 27, because thinking about what I said earlier about it being an enlargement, it just means the volume's getting 27 times bigger. So if we're going back down to the smaller one, it has to get 27 times smaller. Now 540 divided by 27, without a calculator isn't too bad. 27 goes into 54 twice, so it goes into 540 20 times. So my answer for this one is going to be 20 centimetres cubed, and that's our final answer there. So let's just write that down here this time. So my final answer is 20 centimetre cubed, being the volume of A there. Okay, so we have a slightly different question here because we have some overlapping triangles. So it says in the diagram below that PQ is equal to PR. So we know that this length here is equal to this length here. So therefore, straight away, we know that this is an isosceles triangle. So we'll think about that later. It says S is the midpoint of PQ. So if S is the midpoint of PQ, this line here is the same length as this line here. And that is going to apply on the same side, as this length here is the same length as this length here. So again, we'll think about that in just a second. It also then says, prove that triangle QTR is congruent to triangle RSQ. So Q to T to R is this triangle just here, and overlapping that is the other triangle where we have RSQ, and R to S to Q is just there. So as you can see, they overlap, but hopefully you can see them relatively clearly, and we're going to have a go at proving this one. So to start with, can we see anything that's the same in both? And I think personally the easiest bit to see here is that they both have the same base length. As they both share the same line, that's an easy bit of proof for us to say. So for the first one, I would say QR is the same length in both. There we go. So that's a nice easy one. Same length in both, and that has already proved a side. So we've got our first side proved. Let's think about what else we could prove. Well, another thing that we mentioned was the fact that this line here was the same length as this line here, as it says that that was a midpoint. And we know that because it's an isosceles, if it's a midpoint on both, then both halves must be the same length on either side. So I could also say, and this is a relatively nice one on this one as well, that Q to S is equal to T to R. And we just need to think about how we would give our reason, because both lengths are the same and both are midpoints. Okay,
both, or halves I could say, both halves of the same length side. And you could write that in different ways, but I've just tried to write it in an obvious way there. So both halves of the same length of side. And again, that is a side. So we've got two sides already. We just need to think about what else we can find. And again, it goes back to thinking about the fact that it's an isosceles. We know if this is an isosceles, where these two lengths are the same length, we know that in an isosceles, base angles are equal, as we have our isosceles triangle. So for the final one there, I could also say that the angles there are the same as it's an isosceles triangle. So I can say that angle, and what is it, PQR is equal to PRQ. There we go, and those angles are going to be equal. Let's just get rid of that, that doesn't quite go over the R there. There we go, PRQ. So they are equal because base angles in an isosceles are equal. And it's quite awkward having to write it all, but very important that you write it all down. So base angles in an isosceles are equal. So we've got our 3 points there, that was another angle. So just thinking about what we have an angle in between two side lengths. So therefore, triangle QTR is equal to triangle RSQ. And our reason there is because we have an angle in between two sides. So that is going to be SAS. And there we go, that finishes off our question. So this question here says the table gives information about the languages studied by a group of Year 11 students, and it says that 30 study French, 37 study German and 53 study Spanish, and it says draw an accurate pie chart for this information. So the first thing we want to do is add up all these numbers. So if we add up 30, 37 and 53, let's have a look, that adds up to 120. And I always just write that down over here somewhere near the table, just so I know what the total is, and the total there is 120. So in order to get this to 360, either you just have to think about that in your head, what you multiply 120 by to get to 360, or we could just do 360 and divide that by the total there, which is 120. So 360 divided by 120 is 3, meaning that we're going to have to multiply all of these by 3 to get the angle in each portion of the pie chart. So if we multiply them all by 3, and we'll just write times 3 next to them all, there we go, times 3 times 3 times 3, that would mean that 30 would become 90 degrees, and these are our angles now. We would have 37 times 3, which would be 111, so that would be 111 degrees, which is a bit of an awkward one to draw, and 53 times 3 would be 159, so that is 159 degrees. Now that is the main bit of our working out now. We know all of the angles that we need to draw, we just actually need to draw them on correctly. So when you've got your pie chart drawn like this, if it's given to you, if not, you're going to have to use a compass just to draw a circle. And if you're making notes on this, I would definitely do that. I'd just get your compass, draw a nice circle, just make sure that you know where the centre of that circle is, so that you can draw this nice straight line going up so you have a place to start from. So let's start with drawing on this French one, which is 90 degrees. And we can put them all in at the same time, but let's do the first one. So get your protractor, pull it over the top of the pie chart, make sure that little crosshair in the middle is right on the centre. And there we go, I'll just do that really nice and carefully. And then you also want to rotate your protractor so that the guideline where it starts at 0 is lined up with the line that you're starting from, which is the one that's vertical. So there we go, that's nicely lined up. So I want to mark on 90 degrees. So I'm just going to mark the 90 degrees over there. There we go, pull your protractor out the way. And then with a ruler and a pencil, from that central point, draw a nice line over to that. And you can obviously do it a little bit shorter, just to the edge of the pie chart. And there we go, that's your 90-degree angle. Now you can move on to the next one. But before you do, what I tend to do is I normally tend to label that section. So I'm just going to put French in there. So I'll put French in, and I'll also put the degrees in there, 90 degrees. You could also put the 30 in there as well, but just to keep it a little bit simpler on the screen, it's going to leave it as French with the 90 degrees. Okay, so putting your protractor back onto the centre, Now we just want to rotate the protractor around so that the 0 is lined up with our new line, so we can carry on from that point. And again, I'm using the outside numbers. And now we need to do 111 degrees. So past the 90, 110, 111 is just past that, and you're going to have to just get it as accurate as you can. There we go, there's 111 for me. Again, just pull that protractor out of the way, and we can draw in a nice straight line again from the centre. So from the centre, ruler and a pencil, join it up. I'm just going to shorten it a little bit. There we go. You can do that a little bit easier when it's not on a screen, but there we go. Using your ruler and a pencil, I'm just going to label that. So that would be German. And that was 111 degrees. There we go. And the last part of the pie chart here, which, as we only have one left, is Spanish. So we'll label that as Spanish. And that is 159 degrees. A good bit of practice here that you should do is you should stick your protractor on, just measure that final angle there. So I'm going to flip it around the other way, measure to see if that's 159. Might be a little difficult for you to see on the screen there, but that comes out as around 159 for me. So I'm happy with that. It's an accurate pie chart. All of the angles match up to what I wanted them to. And there we go, there's your pie chart. Okay, so that's how you go about drawing it. That's how you get the angles. Remember, they've got to add up to 360. So that bit of working out there where I added up the total and did 360 divided by that total allowed me to see what I needed to multiply all those numbers by so that they all added up. And another good bit of practice that you could do is take those three numbers and just add them up, and you can actually see 159, 111 and 90 do all add up to 360. So we've definitely got it right. Okay. Okay, so we've got some slightly more numbers in this question and a bit more information. If you have a look at the first line, look, it says there are 20 men, 10 women and 10 children. So we've got 3 bits of information in this question now instead of 2. It says the mean score for the women is 15.6 in this competition. The mean score for the children is 9.2 and the mean score for all 40 is 11.2. So again, we are missing one of the bits of information there. Look, we're missing the mean for the men. So it makes sense that the next line then says work out the mean score for the men. So let's just start linking these up and start multiplying them out. So let's have a look. We've got 20 men, and that's not been given, we've not been given any means for that, so we're going to have to skip past that one. We've got 10 women, and it says the mean for the women is 15.6, so straight away we can times that by 10, so 15.6 multiplied by 10 gives us a total score for the women of 156. Then we're on to the next one. Let's have a look what we've got. We've got 10 children, and it says the mean score for the children is 9.2, so we can do that as well. We can do 9.2, multiply that by the 10 children, that gives us their total score of 92. Now the next one, and this is normally the one you just need to be careful on because this now tells us the mean for all of them. Now the total for all of them, look, we've got 20 men, 10 women and 10 children, so we've got 40 people in total. There we go. So it does actually say that in that last line there. It does say the mean score for all 40 people, but if it doesn't, just remember that's where you get it from. So it says all the 40 people's total mean is 11.2, so let's just times those together. We've got 11.2 multiplied by the 40 people. There we go. I'm just going to do this on the calculator just to speed things up a bit, and that gives us 448. There we go. So we've got our overall total there of 448, and we've got the women and the children's total. So we'll be able to work out the total for the men now. We just need to do the overall total 448, and we're going to take away the 156 and take away the 92 and see what our total is now. So take away 156, take away 92, and we're left with 200. There we go, and that there is the total for the men. Now we can finish off our mean again, just like before. Don't forget there are 20 men, so now we've got their total 200. We can divide that by 20, and 200 divided by 20 is 10. There we are, and there is the mean for the men there. Right, let's just highlight that. There we go, there's our final answer. So there we go, that's how you do a reverse mean. You just multiply the mean by the actual amount of people that it relates to, or the amount of things it relates to, just depending what the context of the question is. And then obviously just use a bit of logic to find any totals that you're actually looking for, obviously before then working out the mean in your final step. So this question says, Rosie has 10 boxes of drawing pins. She counted the number of drawing pins in each box, and this table gives some information about her results. Now we can see in the table, we've got the boxes with 29 drawing pins there. There was 2 of those. The boxes with 30 drawing pins, there were 5 of those, and so on. 31 where there were 2, and 32 drawing pins, there was only 1. And it says work out the mean number of drawing pins in a box. Now we know hopefully when we're working out the mean, you add up the total of all the different
boxes of drawing pins here, and we divide by how many boxes there are. And this question's nice, it actually tells us that there's 10 boxes. So we know that we just need to get the total and divide by 10. Now obviously this information is within a table, so we don't have our normal list, although we could actually imagine what we would do if we had a list. Now if we did have a list here, now 10's okay, but once we start getting to tables where there's 80, 100 things in the table, we won't want to do it in this particular way, but just so you have an understanding of how and why we do the process we do, we'll have a look at this first one. So we've got 2 boxes of drawing pins that have 29 in, so we'd have 2 29s, so 29 and 29. Then we've got 5 with 30 in, so 30, 30, 30. You can already see it's actually already a bit annoying having to write these all out. 30 and 30, there we go. We've got 2 with 31, and another 31, and we've got 1 with 32 in. So I could just give you this list here and say work out the mean, and what you do is you just add them all up and we would divide by 10. So with this particular table we could actually just take that approach, it'd be nice and easy to do so, but obviously as I said, as they get a bit trickier we're not really going to want to take that approach. But essentially we're going to have a look at what the totals of all the numbers are, and what we're going to do, obviously because they're categorised, what we're going to have a look at is we're going to look at the total of these 29s to start with. Now there's 2 of them, so 2 29s, we could add those together and we get a nice total there, and that is 58, that total. Then we would have a look at the 30s and we'll add all of those up. We've got 30, 60, 90 plus another 2, 120, 150. So the total of those is 150. The total of the 31s is 62, and the total of that 132 there is 32, and then we can add them all together as groups. Now what we're going to do is we're going to take that away from the list and have a look at it from the table. So we'll get rid of all of that, and we'll do it from the table here. So we've got 2 29s, and all we have to do is times the 29 by 2, and that gives us their total there. So 2 lots of 29, we've already said, is 58. Then we've got 30 lots of the, well, 5 lots of the 30s, and that was 150. We've got 2 lots of the 31, that's 62, and 1 lot of the 32, and that gives us 32 as the total there. Now throughout these questions they could be calculator, they could be non-calculator. I am just going to use a calculator, although I've got to be honest, I think this question is a good non-calculator question, but as long as you know the process. Obviously if it was a calculator question it would be quite nasty numbers, one that you wouldn't be expected to do without a calculator, but they could be non-calculator as well, and here's an example of one I think where this could be non-calculator. So let's have a look. Now we've got all these totals for each row, we can actually just add those all together. So 58 plus 150 plus 62 plus 32 gives us the overall total there of 302 for the total number of drawing pins in all these boxes. Now we already know we're going to divide by 10, as it says in the question up there that there's 10 boxes, but if we didn't actually have that piece of information we could find that because we've got the total frequency just here. And if we do 2 plus 5 plus 2 plus 1, we get a total of 10 boxes. So all we need to do to finish this question off, to get our value of the mean, is we're going to do 302, the total of all the drawing pins, and divide it by the 10 boxes. As you can see, that would obviously be why this might be a non-calculator question, because dividing by 10 is nice and easy. We just hop the decimal in and we get the answer 30.2 for our mean. So in terms of a process there, look, we times across, we get all the totals for each category, we add them all up and divide by how many things there are, and in this case the things is the 10 boxes, and we get that just by adding up the frequency column down here. So there we go, get the total, divide by the total frequency, and you have got your mean. Now it says Hannah is planning a day trip for 195 students, and she has a sample of 30 where they want to go, and each student chooses a place. It says the table here shows the information about her results, so we can see that there's people that want to go to the theme park, the theatre, the sports centre and the seaside. And it says work out how many of the 195 students you think will want to go to the theme park. Okay, so we're just looking at the theme park here, which is just here. And it says state any assumption you make and explain how this may affect your answer. Okay, and we'll have a look at that a bit when we finish. First of all, let's try and work this out. Now there's a couple of different ways that we can do this. I'm going to discuss the non-calculator method to start with, as this is quite a nice non-calculator question. Now it obviously says that she takes a sample of 30 students. If it doesn't say that, we can get that from the total down here, and we get a total of 30. Now in terms of the students that want to go to the theme park out of the sample, well, there are 10 students in the sample, so that is 10 out of 30 students. Okay, so that's 10 out of 30 that want to go to the theme park. And if we simplify that fraction, that simplifies down to 1/3, okay, dividing the top and bottom by 10 there. So what we can say is that we know 1/3 of the students, based on the sample, are going to want to go to the theme park. So if she's going to ask 195 students, then we just need to work out 1/3 of the 195 students that she's planning for. So we could work that out. We could do 1/3 of 195. And obviously if we're doing this without a calculator, we're going to want to use a bit of bus stop here. So 195 divided by 3. 3 goes into 19 6 times up to 18, remainder 1, and then it goes into 15 5 times. There we go. So our answer here would be 65 students, okay, that we are expecting to want to go to the theme park there. So that's obviously a little non-calculator method. It works quite nicely for this question here, but they're not all going to be non-calculator questions, so we could have to do this in a calculator way as well. Now, if we've got 30 people in the sample, essentially we want to figure out how do we get that 30 to represent 195 students in a way. So how do we get from 30 to 195? Okay, we've got 195 that we want to go. So if we figure out how we can turn this and scale it up to 195, we can figure out how many 30s go into 195. So if I can do 195, I could divide it by 30. Let's do this on the calculator. And that equals 6.5. Let's just write that down. There we go. So essentially all I need to do is multiply all of these by 6.5, and that would get me to the appropriate amount. Now it only wants the theme park, but I could go and multiply them all, and 10 times 6.5 is equal to 65. There we go. So we can find it that way as well. Okay, just figuring out how many times that sample has to fit into the total amount. Sometimes that's not going to be very nice, as you might have spotted the one below. If I do 5 times 6.5, that would give me 32.5 people, and obviously we can't take 32.5 people, so you'd have to end up rounding some of these and sort of doing that appropriately, and it doesn't always get you the perfect answer for some of them, but it does here for the theme park. It gives us a nice whole number there. Okay, so two different methods that you can approach. One is just looking at what fraction of the sample want to go to that place and then finding that fraction of the total. Or you can figure out how many times does that sample fit into the total amount. So that's what we did there. How many times did 30 fit into 195? And that meant that we just had to scale them up and multiply them all by 6.5 to get our total there. Now for the finishing part here, it does obviously state any assumptions you made and explain how this may affect your answer. I'm not going to write this down, but essentially we are assuming that the sample is going to represent the 195 students. Now obviously probably in real life that's probably not the case. It's very unlikely that exactly 1/3 are going to want to go to the theme park. But in terms of how this may affect your answer, if we are wrong, okay, there could be more students that want to go to the theme park, and likewise there could be less students that want to go to the theme park, okay? So we are assuming that the sample represents all the students, and if we are wrong, there could be more or less students, and actually thinking about real life, it's more than likely there are going to be more or less, okay? But it gives us a good estimate in terms of how many students want to go to the theme park.
Okay, so for this question here, it says an electronic game can show red, blue, green or yellow. The table shows the probability that one of these colours will be shown, but it's missing the probability in blue. Now before I even carry on, I know I'm going to have to work that out. So we may as well go ahead and work that out, but it does say in part A, work out the probability that the colour shown will be blue. So in order to work this out, we know that these probabilities have to add up to 1. Okay, now at the moment, if we add together what we do have, we've got 0.15, 0.48 and 0.24, and in total they add up to 0.8. So if we take that away from 1, it leaves us with what's left over, and that comes out as 0.2. So the probability of blue is 0.2. Now that's fine to give your answer as a decimal, but of course you could give your answer in a multiple of ways here. You could say that it was 2/10, 1/5, or even 20%, and that's absolutely fine, but when the question is mentioning decimals, I will always give my answer in the same form that it's given in the question. Part B here, it says Janice is going to play the game 50 times, work out an estimate for the number of the times the colour will show yellow. Now obviously yellow means we need to use this decimal here this time, which is 0.24. Now again, there's a couple of different ways of working this out, but 0.24 as a percentage is 24%. So you could work out 24% of 50 and that would give you your answer. As well as that, you could treat it as a decimal or a fraction. In this case, where we're using a calculator, using the decimal is much easier because to work out 24%, you just multiply by 0.24, which is the decimal that we're given. So to work out our answer, we'd just take the 50 times that she's going to play the game, we'll multiply it by the decimal related to the colour we're looking for, which is 0.24, and this straight away gives us our answer. That answer is 12. So in terms of our estimate here, we'll estimate that she's going to get 12 yellows if she plays this game 50 times.
Okay, there we go, that's the end of the video. Well done for sticking through. Obviously, I wish you the best of luck in your paper 2, and I will see you for the next video where we'll be looking over paper 3.